Good morning, Minu. We can start off.
Good morning to all. Sir, my audio is... Sir, can you hear my audio? Is it okay?
Yes, it's fine.
Thank you, thank you. Good morning to all. I am Meenu Vijayan, Joint Convener of HSC Forum. Our time is now 9 a.m. We are commencing our program. Welcome to all of you to this program to observe 13th October 2022 as International Day for Disaster Risk Reduction organized by HSC Forum of National Safety Council Kerala chapter. We start the program with a revisit of safety zone.
എന്തെല്ലാം സുരക്ഷകൾ എനിക്കായൊരുക്കി നീ, എന്തെല്ലാം അറിവുകൾ എന്നിലേക്കൊഴുക്കി നീ, എന്തെല്ലാം സൗഭാഗ്യം എന്നെന്നുമേകി നീ, എല്ലാം അറിയുന്ന പരമ്പൊരുളെ നിന്നെ എത്ര നമിച്ചാലും മതി വരുമോ. എന്തെല്ലാം സുരക്ഷകൾ എനിക്കായി ഒരുക്കി നീ. പുലരി പിറക്കുമ്പോൾ നിൻ കരസ്പർശങ്ങൾ പുൽകിയൻ മേനിക്കുണർവേകണം. പുലരി പിറക്കുമ്പോൾ നിൻ കരസ്പർശങ്ങൾ പുൽകിയൻ മേനിക്കുണർവേകണം. ആപത്തൊട്ടില്ലാതെ കർമ്മനിരതനാകുവാൻ, ആപത്തൊട്ടില്ലാതെ കർമ്മനിരതനാകുവാൻ കാത്തിടേണം പ്രഭോ നിത്യമെന്നേ. എന്തെല്ലാം സുരക്ഷകൾ എനിക്കായി ഒരുക്കി നീ, എന്തെല്ലാം അറിവുകൾ എന്നിലേക്കൊഴുക്കി നീ, എന്തെല്ലാം സൗഭാഗ്യം എന്നെന്നുമേകി നീ, എല്ലാം അറിയുന്ന പരമ്പൊരുളെ നിന്നെ എത്ര നമിച്ചാലും മതി വരുമോ. എന്തെല്ലാം സുരക്ഷകൾ എനിക്കായി ഒരുക്കി നീ.
Thank you. I now invite Sri Nayan Nandakumar, convener of HSC Forum and Senior Associate Vice President of Carborundum Universal Limited, to deliver the formal welcome address. Over to you, sir.
Thank you. Good morning, respected dignitaries, distinguished guests, and dear members of National Safety Council and safety professionals. Welcome to all of you. 13th October is designated as International Day for Disaster Risk Reduction by United Nations with the objective to promote a global culture of disaster risk reduction. The Sendai framework has 7 global targets and 38 indicators for measuring progress on reducing disasters and losses. In 2022, the International Day will focus on Target G of the Sendai framework with the tagline, Early Warning and Early Action for All. We at National Safety Council Kerala chapter have been actively engaged in promoting mass awareness in disaster prevention and mitigation on this day since 2019. Today, it is a pleasure as we once again come together to reiterate our commitment to building a safe planet on this important day. We are delighted to have with us today Shri P. Pramod, Director of Factories and Boilers, Government of Kerala, who is also the Chairman of National Safety Council Kerala chapter. The vision of zero accident in Kerala was first articulated by him, and he played a pivotal role in bringing together various agencies, including government, NGOs, media, and communities together on a common platform to create awareness and reduce disaster risk and losses. He has provided the leadership in ably steering the various agencies and aligning them towards the goal of zero accident. On behalf of NSC-Kerala chapter and HSC Forum, I extend a warm welcome to Shri P. Pramod, Director of Factories and Boilers and Chairman of National Safety Council Kerala chapter. Welcome to you, sir. We are privileged to have with us today one of a highly acclaimed, renowned professional and an outstanding human being, Professor Dr. Anil Gupta, Professor and HOD, Director of Projects and Center of Excellence, National Institute of Disaster Management, New Delhi, as our chief guest today. He has been most gracious to accept the invite today, notwithstanding the busy schedule already committed by him from 10 a.m. onwards. We are very thankful to you, Professor, for wholeheartedly accepting our invitation. We sincerely appreciate your kind gesture to be with us today. Your message on this day will go a long way in helping us chart our future course of actions in disaster management. On behalf of NSC Kerala chapter and HSC Forum, I extend a very warm welcome to Professor Dr. Anil Gupta. We are also joining us from NIDM, Dr. Kopal Verma. Warm welcome, madam, to this program. We have 3 eminent speakers today sharing their thoughts and knowledge. Mr. Siad B, Chemical Inspector, Safety Cell and Officer in charge of OSH training, factories and boilers, needs no introduction. He's a popular and well-recognized face and known for his passion in driving safety programs through the novel Suraksha Ratham. He will be enlightening us with case studies related to industrial disasters and prevention methodologies. His talk is surely going to be very interesting, considering his wide and extensive practical hands-on experience. Mr. Raju Pattathil Shashidharan is a certified safety expert who will be sharing his thoughts on the role of process safety management from concept to operation in preventing industrial disasters. The topic will no doubt kindle the interest in participants in understanding the evolving trends and methodologies in disaster prevention through process safety management. Not everybody has had the luxury of participating in an off-site mock drill. A mock drill needs elaborate planning, preparation, and involvement of multiple agencies. Mr. Dilip Madhavan, Senior Manager from Petronet LNG, will be sharing such a case study, which is sure to be very important and informative to industry professionals. On behalf of National Safety Council Kerala Chapter and HSC Forum, I extend warm welcome to the distinguished speakers of the day, Sri Siad B, Sri Raju Pattathil Shashidharan, and Sri Dilip Madhavan. Success of any event depends on the wholehearted presence of participants. We are delighted to see the active presence of professionals from across various industries, safety professionals joining us today. On behalf of National Safety Council HSC Forum, I warmly welcome all distinguished delegates and participants to this program. Thank you. Jai Hind.
Okay, thank you, sir. Now I invite Sri Pramod sir for delivering the presidential address. But before that, may I request Sri Vipin Das, Head EHS, Sudgami Clarion, to formally introduce Sri Pramod sir. Over to you, sir. Vipin sir.
Just hold on. I think we'll have to unmute Vipin.
Thank you, Meenu. It is our pleasure to have Sri P. Pramod, Director of Factories and Boilers, Government of Kerala, and Chairman of National Safety Council, Kerala chapter with us today. In spite of his very busy schedules, Pramod sir has always found time to guide us, handhold us, and walk the extra mile to take forward any initiative towards reducing accidents and disaster prevention. It is his passionate zeal, enthusiasm, and support that has culminated in today's program on this important day of industrial disaster risk reduction. Sri Pramod, after completion of BTech in Mechanical Engineering, has more than 25 years of experience, which includes his academic accomplishments includes LLB with 7th rank from University of Kerala, MBA in Safety Management from Annamalai University, postgraduate diploma in Disaster Management from Indira Gandhi National Open University, postgraduate diploma in Electrical Safety from Annamalai University, diploma in Industrial Safety from Annamalai University. He has also undergone training in accident prevention techniques and OSH management system at Occupational Safety and Health Administration Training Institute, OTI, Chicago, Department of Labor, USA. He is the recipient of many awards and accolades, which includes State E-Governance Award from the Honorable Chief Minister of Kerala for making complete digitalization services of Department of Factories and Boilers. Received the Scotch Order of Merit National Award for Factories and Boilers Online System FABOS in the year 2016, 2017, 2019, and 2020. Recipient of Best Safety Article Award from National Safety Council of India in the year 2013. Selected as OSH expert from India for exchanging of knowledge and information among SAARC countries. He has presented papers in many international and national conferences, which includes conference presentation on management of industrial disasters, new strategies and vision at Asia Pacific Occupational Safety and Health Organization APOSHO conference held in the year 2016. He is an active member in many government organizations, which include Energy Management Center, Kerala State Pollution Control Board, member State Level Electrical Accident Prevention Committee, Vice Chairman, Chemical Emergency Handling Society, Kakinad, Ernakulam. Dear sir, we are privileged to have you with us today for delivering the presidential address. Over to Pramod sir. Thank you.
Thank you, Vipin. Am I audible?
Yes, you are audible, sir.
Yes, sir.
Respected chief guest of today, Dr. Anil Gupta, Professor and HOD, National Institute of Disaster Management, New Delhi. Sri Nandakumar Nair, Convener, HSC Forum, and Head Manufacturing and Projects, Carborundum Universal Limited. Eminent speakers who are handling various sessions in today's program. Sri CRB, Chemical Inspector and Officer in charge of Occupational Safety and Health Training Institute, Kakinad. Sri Dilip Madhavan, Senior Manager Fire from Petronet LNG. Sri Raju P. Shashidharan, Certified Functional Safety Expert from Cochin. Dr. V.M. Ramesh, Secretary, National Safety Council of India, Kerala Chapter. Srimati Meenu Vijayan, Joint Convener, HSC Forum. And Sri Vipin Das, who made an introduction about me. And all safety professionals, employees, other eminent experts who are participating in this program, ladies and gentlemen. We all know every year October 13th, we observe this day as International Day for Disaster Risk Reduction. This is the fourth time National Safety Council of India Kerala chapter, under the initiative of HSE Forum, is observing this day. So in this regard, I wish to congratulate Mr. Nandakumar, who is the convener of the HSE Forum, and he is the brain behind this coordinating all these activities, and also not only the International Day for Disaster Reduction activities, but also in HSE Forum, lot of programs here he organizes in his leadership. I congratulate Mr. Nandakumar and his team, and also joint convener Srimati Meenu for organizing this program in a wonderful manner. Today, I am very happy and proud to know that Dr. Anil Gupta is a professor and director of projects and climate resilience and disaster, National Institute of Disaster Management, New Delhi, is going to inaugurate this program. So 2-3 times I attended various programs in National Institute of Disaster Management, NIDM, New Delhi. I know him personally. I attended his classes also. So that very eminent professor of the NIDM is going to inaugurate this program. It's a very good thing as far as the NSC is concerned. We all know this year, that is 2022, the International Day will focus on target G of Sendai framework. That is substantially increase the availability of and access to multi-hazard early warning systems and disaster risk information and assessments to people by 2030. This target aim how people and communities around the world are reducing their exposure to disaster and raising awareness about the importance of reining in the risk that they face. We all know every disaster has 3 phases, that is pre-disaster phase, during disaster phase, post-disaster phase. Pre-disaster phase consists of prevention, mitigation, and preparedness. During the disaster phase consists of response activities. Post-disaster phase consists of rehabilitation, recovery, and reconstruction, etc. As a government officer committed to work in the pre-disaster phase of industrial disasters, that is to prevent and mitigate the industrial accidents or industrial disasters, let me explain the steps taken by the Department of Factories and Boilers and National Safety Council of India, Kerala chapter in this regard. Before that, let me recollect the words of Honorable Past President of India, Pranab Mukherjee, while holding the post of Defense Minister in Central Ministry. He stated that we are spending around 3 to 4% of our GDP for during disaster and post-disaster activities. If we are able to spend 0.1% of GDP in pre-disaster activities, we can save crores and crores of rupees. So another fact is that as per the ILO reports, every year 2 million workers in the world die due to industrial accidents and occupational diseases. Goal 8.8 of the Sustainable Development Goal 2030 of UN also focus on the reduction of industrial accidents and diseases. Second strategic conference on occupational safety and health at workplace, organized by European Economic Council, in which also fifth strategic pillar focus on the Vision Zero industrial accident concept. Moreover, as per the judgment of the Honorable National Green Tribunal, around 15 major accidents, including styrene gas leakage and LG polymers, Vaishak, were occurred during the past lockdown period from 1st June 2020 to 31st March 2021. And as a result, so many persons were died and injured. So there was utter failure of early detection and warning system provided at the factory, and disaster risk information was not provided to the inhabitants of this factory. If we go through the High Power Committee report and analyze the data regarding the past industrial accidents, it can be seen that the present traditional approach has not attained any momentum in reducing the accidents or disasters. So as aimed in the target G, it is the need of the hour to develop early warning system by using latest technologies and provide disaster risk information to people. The Department of Factories and Boilers, Government of Kerala, working in the pre-disaster phase, of industrial disaster, adopt triple strategy, that is engineering, education, and enforcement. Regarding the engineering strategy, before commencing the construction of major accident hazard factory in Kerala, site appraisal committee constituted after the Bhopal gas disaster considered the site suitability after assessing the individual and societal risk based on the hazard identification and risk analysis reports and site inspection. In addition to that, while granting license and approval of factory construction permits, department ensure the safety of workers as well as the public from plant and machinery, including the fire safety norms as per the statutes. In education strategy, the department provides safety education and awareness program for workers through the newly set up Occupational Safety and Health Training Institute at Kakinada. This is the first institute in occupational safety and health in India, and providing basic safety awareness to school, college, ITA students using the mobile safety training vehicle, that is Suraksha Rhythm. National Safety Council Kerala chapter is also conducting safety audit, hazard identification and risk analysis, etc., and providing safety training programs through our Safety Training and Research Center, that is STARC, Kochi, for workers of hazardous and other industries, and safety awareness program for students also. So, in addition to that, recently National Safety Council of India, Kerala chapter has associated with Accident-Free Cochin Mission aimed by the GCDA, that is the Greater Kochi Development Authority. Since every year, around 4,000 people die due to road accidents alone in Kerala. So in addition to that, electric safety survey was conducted in houses to give a report to government regarding the measures to take to avoid electrical accidents and electrical fires in Kerala. In enforcement strategy, department implemented a scheme for inspection, namely WERBIS, Web-Enabled Risk-Weighted Inspection Scheme, by which factories are classified based on high, medium, and low risk category, and also conduct priority inspection at MH factories by a group of mechanical, chemical engineers and doctors. As a part of international cooperation in capacity building and occupational safety and health skill enhancement, Department of Factories and Boilers organized various programs and conclaves in association with the DGUV Germany, International Social Security Association, ILO International Training Center, and PRODAIR USA, etc. As a part of disaster risk reduction and preparedness program, department approved the on-site emergency plan of all 40 MAH factories in the state of Kerala and monitor the periodic mock drills conducted by them. In addition to that, district crisis groups with the district collector as chairman and inspector of factories as member secretary were formed in all, and offsite emergency plan were prepared in all districts of Kerala where MAH factories are located, and also conducted offsite mock drills in association with National Disaster Response Force. You all know another flagship early warning and disaster risk reduction program of the department is ROSES, that is Remote Sensing Enabled Online Chemical Emergency Response System, which is the joint venture program of the National Remote Sensing Agency, Hyderabad, Indira Gandhi Center for Atomic Radiation, Kalpakkam, Tamil Nadu, and Department of Factories and Boilers. This is a very unique and the first project in India after Bhopal gas disaster to provide an early warning and alert system for inhabitants and first responders at the time of toxic gas release from MH factories. With these few words, I conclude my presidential address. Thank you. Thank you very much.
Thank you, sir. You talked about the 3 phases of disaster, but the focus definitely has to be on the pre-disaster phase, and the government focus were steps taken by the government and National Safety Council under your leadership with Zero Vision. You shared extensively and very elaborately on the various measures taken for the early warning system. And as you said, the need of the hour is to create that more and more to make a robust system in our country. Factories and boilers has historically been associated as an enforcement agency. I think we are very happy and delighted to see that under your leadership, it is moving beyond that role to a strategy and engineering, wherein a lot of activities are being taken. and initiatives are being taken under your leadership to create a safe environment, especially in state of Kerala. Thank you, sir, for the message of safety. It's now time to hear from our chief guest, Professor Dr. Anil Gupta, Professor and HOD, Director of Projects and Center of Excellence, NIDM Delhi. I request Dr. V.M. Ramesh for introducing our honored guest.
Morning, sir. Sir, am I audible? Hello? Hello, can you hear me, sir?
Sir, you're audible.
Okay. Dr. Anil Gupta, having 3 decades of experience in diverse environment, working with government, corporate, academic, research, and international projects. He is the Director of Projects and Center of Excellence, Head of Division, E-Learning of National Institute of Disaster Management, New Delhi. He holds a master's degree in environment, biology and health, completed his PhD at the age of 24. That is, we have to give him a big applause because he has completed, because I had completed PhD at the age of 60. Okay, okay, right. At the age of 24, he holds an LLB degree and completed postdoctoral at CSIR in Niri, Nagpur in 1994-96 in the area covering impact and risk analysis, environment policy, greenhouse effect, modeling and developmental planning process. He has won Young Scientist Award, Government of Madhya Pradesh in 1996 in area of environment and forestry, Excellence Award of Society for Environment and Occupational Health, New Delhi in 2012. And prior to joining National Institute of Disaster Management, he was working with Bandakal University Institute of Environment and Development Studies, Uttar Pradesh till 2006. And he served in Ambedkar Central University, Lucknow. And he is also associated with the Disaster Management Institute, Bhopal. He served there as Assistant Director. And I am also associated with Sri Gupta ji because I had participated in lot of webinars in which he has invited me, and also I am thankful to Kopal Verma ji also, who has invited me and given me an opportunity to speak on the disaster management. And I thank him also. He has to his credit 180 publications to his credit. And today we are thankful to him for this, as our Pramod sir has rightly told. This is the only chapter in India who is observing this International Day for Disaster Risk Reduction 4th time. We had started in 2019 with a physical program with 10 beautiful presentations from industry. The best practices followed, and after that COVID has given us the chance of going to online. Otherwise, we would not have received you for this beautiful function. And I am thankful to COVID also, which helped us to have you here. Thanks a lot, sir. I invite you, sir. I invite you. Okay.
Am I audible?
Yes, sir. Yes.
Thank you. Thank you so much for your generous and nice introduction. And first of all, the compliments and best wishes to each and everyone on this International Day for Disaster Risk Reduction. My special compliments to National Safety Council, more particularly the Kerala chapter, and the Department of Factories and Boilers of the state of Kerala. As it is very significant to highlight here that India as a whole is a multi-hazard prone country. India is one of the highly hazard prone countries of the world. And if we look in terms of disasters, regularly one or other disasters is always following some or other part of the country. In the same way, Kerala, even being a small state, has a special significance. It is prone to a number of natural hazards, but it is also a highly industrialized state, and also lot of incidences of chemical and industrial risks are also there. But on the other hand, the way the state of Kerala, the government of Kerala, more particularly the Department of Factories and Boilers, the Disaster Management Authority, and other officials associated with the authority, and the National Safety Council people have taken this subject with great interest and cooperation. I think the most important thing is cooperation. And this has been witnessed in the past disasters as well. When Kerala got the flooding, I think very fast and very effective kind of coordination in response and relief to people, that is always quoted. Beside this, every disaster also tells us or gives us some lessons from disasters and for improving in future. Kerala has also been in the forefront for identifying those lessons, even conducting of post-disaster damage and needs assessment. In very less time, in the state of Kerala, we could raise the people from various engineering colleges, people from various voluntary organizations, people from various industries to join the team, and a very record time that kind of assessment has been undertaken. So this is very important, and I would compliment the entire team who has conceived today's program, which is the fourth in the series of the event on International Disaster Risk Reduction Day. When it comes to theme of early warning and early action, I think this is very pertinent in terms of both natural disaster risk reduction as well as industrial disaster risk reduction. In case of industrial disaster risk reduction, we have the concept of zero tolerance. That is the reason, if we have the proper capacity building, if we have the proper technical assessments in place, checks and balances in place, we can bring the risk of disasters to near zero. Although we believe that risk can never be brought to zero. So we always have to have a good level of emergency preparedness, so that whenever there are any kind of eventualities or mishaps, that should not convert into disasters. So that is the ultimate motto. Second thing, early diagnosis of the challenges. I think that is very important, because any kind of disaster always gives some signals or some kind of early warnings. Even in case of industrial mishaps also, if we recall the Bhopal incident, Mr. Pramod ji and other people who have also seen the Bhopal incident from the close analysis, they have analyzed, they have been studying these kind of disasters in the past. And if we look at the Bhopal disaster, we find that around 6 months before, prior to the Bhopal major accident took place, there was a minor incident where, because of the phosgene exposure, one person of the industry had died. So it was some indication that something about maintenance is going wrong, something about maintenance is poor, something about safety system, there is something wrong, or some loopholes are there, or serious checks and balances are not there. Even I often refer to the Kolkata flyover collapse, or Mumbai footover bridge challenge, or any kind of disaster that always gives some kind of signals. So the procedural approach to early warning is one, but second thing, identifying these signals which already come as an alert and warning is also very important. Understanding that something is going wrong, something is poor, something is not being taken care properly. I think those are also very different kind of early warnings we need to capture on. Then early preparedness is certainly very, very important. We, in case of natural hazards, at some places we have good preparedness. Sometimes we try to mobilize the resources when disasters are there. There is always a clear distinction we see where there is always already a prevailing level of preparedness. We always find the response is very effective and loss of life is reduced. But when it comes to chemical and industrial disasters, besides the emphasis on worst case scenarios or major accident hazards, I often say that yes, we agree that the worst case scenarios are important. That is often taken into consideration in our risk analysis and the consequence analysis in our risk assessment or disaster management plans and MAH units. But I say that equally important is to emphasize or to consider the lower order risks. If we keep on ignoring lower order risk, it is certain that someday we are going to meet a major risk or a major challenge. So these lower order risks, where a minor deviation can have misses or near misses, I think it is also very important to record not only the mishaps or the incident which we call at misses, but also the near misses where something was about to go wrong but didn't go wrong. I think those are good lessons. And I often refer that we also should come up an initiative, and National Safety Council, NIDM, and the state, the factories and boilers are in some state, we call it Directorate of Industrial Health and Safety, jointly with the relevant ministries at various levels. We have to come out with a approach to have our own failure data of India, because we have good number of, or I would not say use the word good, I would say that ample number of mishaps or accidents, those are occurring in India. So we should also look at that how we develop our own failure data. We often, with the risk assessment, we use the failure data from abroad, the British data or so. So I think that is also important aspect. Then second thing, the vulnerability is also very important. When we conduct risk assessment, what is the time of that event that taking place? Which is the night time? Which is the morning time? Which is the shift? How many people are maybe there at the site? And then what are the vulnerability aspects there? Those are also very important in the consequence assessment. So not only the physical effect modeling, it is the consequence assessment that is also very important. Then when we refer to the Government of India's initiative, where we also refer to the Prime Minister's 10-point agenda, and the agenda number 8, the item number 8, that is emphasize local capacity building. I think when it comes to local capacity building, we often refer to the National Safety Council and UNEP program that was called as APEL. And now APEL is not in India, but we have to think of this kind of program. And I would again relate it with how effectively the government of Kerala and the people of Kerala have engaged the volunteers at various levels, the taluka level volunteers, the district level volunteers. And similarly, we have the volunteers under civil defense, we have the volunteers under various industries. They are having a lot of knowledge and capacities, resources with them. So I think that is very, very important to look at this. The Government of India has 2 legislations which are about to be finalized now. One is a legislation on health, safety and environment, that how we look at health, safety and environment in an integrated way. And second is chemical safety regulations. So I think soon these regulations will be in place, and that will provide much better impetus on this subject. Finally, as an inaugural remarks, I would again compliment the organizers, the Chief Inspector of Factories, the Director of Factories, and all the people of the Department of Factories and Boilers, and all the officials of National Safety Council, and in general, all the people of Kerala and all the people of India who are taking interest in the subject of promoting safety and disaster management. Just 2 days back, I was addressing the faculty members and research scholars at IIT Roorkee on this issue as an inaugural remarks to the celebration of International DRR Day. I tried to convince them and give them a message, and that I would repeat here also. Basically, we have to bring safety concerns into forefront of our thinking process. Whatever we do, safety should be our first concern. If we are going to build a house, safety should be our concern. If we are going to take a house in our rent, we should look about safety. If we are planning a tour, if we are organizing some event or a congregation of 1,000 people, 2,000 people, 10,000 people, or any kind of festivals in the temples or any occasions, safety should become one of the prime concerns when we are planning these kind of things, and that is very important aspect when we talk about promoting a culture of safety, preparedness and prevention. So I think that is very important, and I'm sure that today we are going to have in this program a lot of deliberations which will be touching upon the technical, behavioral and management issues, and also the community involvement issues. So I would not be speaking for long. I'm very thankful for having invited me for this program, for addressing the August gathering at this occasion. I have to join another program starting at 10 a.m. Here itself at India Habitat Center in Delhi. So from the entire program, to my compliments and best wishes to all of you, and great congratulations. And as you were referring about the online programs, yes, these are good opportunities, but I would certainly be looking forward to have a face-to-face program jointly with National Safety Council and the Department of Factories and Boilers in Kerala somewhere, and we shall certainly work together in that direction also. Thank you very much, and once again my compliments. Thank you. Namaste.
Thank you very much, sir. Thank you.
Thank you, Professor Dr. Anil Gupta. Many thanks for being with us today and for sharing your thoughts.
Many thanks for being
and focus areas that we need to work on. As you said, safety has to be in forefront, the first concern on every work, every action that we do. We definitely take forward the message that you have given us today. You also touched upon India's history of being highly hazardous history, and touched upon the Kerala. The need for a very important early diagnosis, which is always a signal of things to come. We will definitely take forward the message. The second message was to have the going with the theme early warning and early action for all. The need for zero tolerance to achieve near zero accident, and the need for emergency preparedness. And we also take to heart your compliments, especially to the government as well as the Department of Factories and Boiler in the role of disaster risk reduction in Kerala. And in this going forward on this, we look forward, as you suggested, joint coming together for of National Safety Council, NIDM and Factories and Boilers of Kerala for evolving more comprehensive approach to disaster risk management. So thank you very much. Looking forward to more such interactions and support from you, sir. And we understand that you have a program at 10 o'clock in spite of being with us. But definitely your message encompassing the safety for all would be definitely taken forward, and we'll definitely come back to you again for guidance and support. Thank you very much, sir.
Thank you. Thank you. Thank you.
We now move on to the program's key speakers of the day. We have first talk by Mr. Raju Pattathil Shashidharan. He will be talking about proactive approach to disaster prevention through process safety management from design to operation. May I request Mr. Vipin Das, Head of EHS Sudkemi, to introduce the speaker.
Thank you, Nandumar sir. Yeah, am I audible? Hello. Yeah. Mr. Raju Pattathil Shashidharan holds a BTech in Instrumentation and Control Engineering from University of Calicut with more than 25 years of industrial experience. He is also a certified PHA HACCP leader from TUFNOD, certified functional safety expert CFSC, functional safety certified professional from TUFSUD, and Chartered Engineer Institution of Engineers, India. He has worked in various capacities in India and abroad. The companies served include 2 years in ONGC, Bombay Offshore, 4 years in BPCL Cochin Refineries, 8 years in Dolphin Energy Limited, Doha, Qatar, and 5 years in Petronas, Kadigali, Kuala Lumpur, Malaysia. His area of experience and expertise includes risk assessments and safety audits, HACCP and LOPA studies, safety integrity level review and classification and verification, functional safety assessments, process safety management system development, maintenance reviews and optimizations, safety critical equipments, equipment criticality reviews, asset life study and life extension, alarm management, control system, cybersecurity assessments, and so on. Today, Mr. Raju will be speaking on the topic of proactive approach to disaster prevention through process safety management from design to operation. I now invite Mr. Raju to have his session. Thank you.
Hello.
Over to Mr. Raju for your session.
Can you hear me?
Yeah, audible, Mr. Raju.
I'm audible. Oh, okay. We will start now, even though it's 10 o'clock is the scheduled time. We can commence now, right? I think.
Yes, sir. Go ahead, sir.
Okay. Good morning to all colleagues, friends, and NSC team members and distinguished guests. First of all, I thank the NSC for inviting me to give some talk on this proactive approach concepts for disaster prevention. Even though this topic is discussed many times, I think the culture starting from the top management, that is a key aspect which needs a continuous enhancement and which will give to greater awareness among the fraternity of industrial engineers, and bring in lot of new concepts which are happening around the world. So a risk-based approach and proactiveness, these are the two key keywords, key points which I want to highlight during today's talk. So if everybody is okay, then I can start my presentation.
You can upload it from your end.
Yeah, this. I'm just trying to.
On the top, do you see that share button? Top right on the screen. There's a share button. Am I audible, Mr. Raju? You are muted. Hello. Some challenges for Mr. Raju. We are just sorting out. In a few minutes, he will be uploading the presentation. Just hold on.
Can you hear me now?
Yeah, audible.
And you can see my screen?
Not yet. Not yet. I think you'll have to share your desk.
Yeah, I have shared. It's already in the sharing mode.
You have to click on the screen instead of sharing the presentation. You share your desktop, and from there you upload you open your presentation. Keep your presentation open, and then share your desktop screen. You can, when you click on that share button, you will see the screen option, not the window option.
Has it come now?
No, sir. When you click the share button, you will see the option screen. You select screen, and then you just open your PowerPoint. It will be visible.
I'm trying to toggle. I should send it to you better. Because I have already given this. Is it okay now? Are you able to see?
Not yet. Can do one option is to send the presentation to me.
I just
And-
sent it now.
Have you sent it to me?
No, I'll send it just now. We do not have your email also at the moment. Can I send in the WhatsApp or it's better? Because NSC Kerala chapter, the email is there. Shall I reply to that? Hello? Hello?
Yeah. You can. I just messaged it. You can send it to my email ID, and then I will upload it for you. Well, let me know once you have sent it. Have you received my message? WhatsApp message?
Yeah. I'm sending now.
You can send it across. So what I would suggest is to save time. We can move on to the next presentation, and then once that is over, you can be by that time we'll have this sorted out.
No problem. No problem.
So, Mr. Siad, you are available? Siad sir, undo. Sir, just hold on. Okay, so I suggest that we start your presentation first. I would request Minu Vijayan to introduce the speaker. And then we can take this.
Okay. Sri Siad B, Chief Chemical Inspector of Safety Cell and Officer in charge of OSH Training Center, Department of Factories and Boilers, Government of Kerala, needs no introduction. He is a well-recognized person across industries. But for sake of formality, allow me to introduce him to you. Mr. Siad completed his BTech from TKM College of Engineering and MTech in Process Engineering from Cochin University of Science and Technology. He is a faculty in Institute of Land and Disaster Management, Trivandrum. He has been involved in conduct of mock drills at Trivandrum, Alapi, Kollam and Kottayam district. He brings with him extensive experience of conducting inspections in all types of industries in Kerala. He anchors in the training program under the novel Suraksha Ratham program and so far has completed 1,000 trainings. Most laudable part is more than 400 of such trainings are
Audible.
Most laudable part is more than 400 of such trainings are carried out in educational institutes, including ITI, polytechnics, engineering colleges, etc. Today's topic, we have one of the best trainers sharing his experience and learning from various industrial disasters. I invite Sri Siya sir to deliver the talk. Over to you, sir.
Thank you, Minu, for your nice comments. First of all, I am sharing my PowerPoint, please. Can you see?
Yes, sir.
Yes.
Okay. Okay. First of all, I am giving. First of all, I express my gratitude for giving me the opportunity. See, what I want to present is that learning from accident is an important way to identify the technical vulnerabilities and potential weakness in the safety management procedures. I will share from my industrial experience some of the accidents and also some dangerous occurrences happened during my career in some of the factories. Normally the industries industries having so many issues like
ഞാൻ അതിലൊരു പാസ്വേഡ് കാണും കേട്ടോ അതിലെ.
hello
ഞാൻ
hello can you hear me?
ഉണ്ടാവണം. സെൻഡ് നോക്കട്ടെ ഒരു മിനിറ്റ്.
Hello.
Excuse me, sir. Can you mute your audio? Sir, Raju sir.
Hello. Yes, I am continuing. I think you all can hear me.
Oh, okay.
Yes, sir. Yes, sir. It's okay.
I am taking only some small incidents for identifying the key factors influence to a disaster, influence that to a disaster. That the key issues is very vulnerable, and we have to be very much identified well before it may proceed to a disaster like that. We have to be very much care in all these things. Some different types of fire incidences happened in various factories. I am not mentioning the name of the factories, but the process and all those things I could not that I have mentioned here, and somebody can maybe may identify the factory. That is not a problem at all, because only thing we are meaning is what is the key behind this disaster like that. The paint factories, plastic industries, oil and gas industries, and pesticide industries, and solvent extraction plant fire incidents, refrigeration plant industry accidents, some steel plant accidents, and petrochemicals, etc. So many accidents we go through it, and so many parameters were involved in the disaster event. I am actually mainly the fire is the result of a chemical reaction. Normally the reaction all knows that there a reactant is there, products are there, some energy also released to the atmosphere. One or more substances also called reactants. That reactants are converted to one or more different substances known as products. In some fire incidents, fuel is there, the fire is the oxygen or air is available, and some reaction occurs. It will come to, normally we are saying carbon dioxide and water with some energy is releasing to atmosphere, and that energy and this fire energy which creates the problems. Actually, what is the parameter significance leading to different fires are varying from one industry to other. So the paint industry fire is not relevant to plastic industry, and the root cause of each and everyone is entirely different. Suppose I am taking the case study of some fire in the solvent extraction plant. What happened in that plant is actually the oleoresins are extracted from spices, and that semi-finished goods are kept in a godown. That godown supposed to be kept under around 20-degree temperature, climatically controlled space. But what happened? Actually, the spices oil extracting from the spices, having some traces of solvents, presence of solvents are in it. This traces of solvent is vulnerable for a fire incident. That is, we have to be very careful. One fine night, around the climate temperature is the storage temperature is around 20 degrees Celsius with the support of a this AC or that cooling system. The material stored inside the storage area, a small traces is released into the atmosphere. That means a small traces, it is minute traces, that traces of solvent. All we know the properties of flammable solvents. Generally property, what we are telling what are the flash point, limits of flammability, vapor pressure, ignition energy, all these things were there. But what is significance of all these specific parameters is very important. Suppose the solvent extraction plant, we are using some the ethyl acetate or hexane, etc., for their extraction of the oil extraction process. They are using this. After extracting the solvent oil from the spices, they are keeping in the semi-finished goods for final purification into a quarantine room for some 2-3 days or 5 days, like that. In storing that room, there is only a trace amount of solvents are present is there. But what has happened that on fine night, the vapors mix with air and as some sort of ignition energy attained, and the entire storage system and the factory into a fire. That is we should have the controlled storage, controlled temperature storage area can generate this type of fire incidents. Is a very we normally we don't identify such hazardous areas in our factories, because only small amount, the oil is normally not a fire hazard, the spices oil not to some extent it is not a fire hazard, but the solvent present in that trace amount is started to burn. And from where these 3 points I have, a flash point and ignition energy and limits of flammability. The significance of these 3 parameters is very important while considering the solvent solvent fires in the industries, because the small amount, the flammable limit, we can see the lower flammable limit is around 1 to 2 other or 3%, and the upper flammable limit will be around 8%. That means between 2 and 8 the chances for a fire is between these areas, because the air is always available in this area, and the thing is that the actually only needed lesser amount of solvent vapors is required for a fire. But in that case, and additionally we required an ignition energy. Ignition energy is also very important parameter. You have to be kept in mind, and that ignition energy create the reaction of fire in that case. That is, ignition energy is we have seen the flash point is also very significant to this. The flash point of the normally all the solvents are minus less than -3, 4, 5, like that. That means the ethyl acetate or whatever it may be, the flash point of different varies from 0 to minus 50 like that. That means the initiation of fire mainly due to three parameters: flash point, auto ignition temperature, and the fire point. These three, we have to identify what is the significance of these three. Auto ignition is without the influence of external intervention, but flash point, in the flash point region, there is stands for a fire in the intervention of a ignition energy. Then what is the ignition energy? That is the main, how much quantity of energy required for initiating a fire is very important. In this case, you can see a video in my slide where somebody is cutting the barrel with the use of a cutting machine. Just the cutting means that barrel is empty. That means it has only a negligible amount of fuel vapor or solvent vapor inside that. Even though that vapor itself explodes, means how this type of instance can be happened in our solvent extraction plants or other highly flammable liquid storage areas. It's very significant. How much energy required? That is also a very important point. The flash point, as I told, the lowest temperature that flammable liquid can generate enough vapor to form a mixture with air that will ignite. That is flash. I will show you some examples of flash points. Some diethyl ether -42, acetone -20, hexane -22.5, ethyl acetate -4. These are all you have to look into it. That means there is these all solvents are ready for initiating a fire if an additional energy is contributing to this this atmosphere, this area. That is a very important thing we have to identify. This minus degrees are the flash points. That means the atmospheric temperature is around 25 degrees or 30 degrees. That is, we have to be very much understand how much lesser amount of temperature all these solvents be. That is, we must be very careful that in that cases also only lesser amount of this solvent vapor is required. That is also the another thing. That the slide you can see ethyl acetate is using 3.5% is lower flammable limit. That is the quantity required for initiating a flash. That is very important. That means that I have told that the solvent extracted this thing contain the lesser amount of traces of solvents due to the vapor pressure that will enter into the atmosphere. Most of the solvents are heavy vapors. They will spread around the lower region, and air is always available there. Then what is the additional requirement is only the energy. What is the energy? That is the unit of energy is joule. And see, all these having lower flammable limit and upper flammable limit. In some cases, our godowns are having heavy amount of solvents, means the vapor level may be mostly above the limit of upper flammable limit, and that cases this small fire doesn't happen like that. But in the case of lower energy area, lower flammable limit area, we must be very much careful. Otherwise, the incidence of initiating a fire is very large. In some cases, we can see the ethylene oxide, acetylene, etc. They have no upper limit. No upper limit means that type of fire can happen anywhere without the presence of oxygen. Without the presence of oxygen means in the confined area also this acetylene gas can giving a flame or that can explode in any area. But in other cases, we can see there is a region. That region is very important. That is, in all those cases, we can see the 2.1 to 9.5, that is for LPG, then gasoline 1.4 to 7.6, then ethyl acetate 3.5 to 15. That region is very important. That region based on this is, first of all, I have told this is a chemical reaction. Chemical reaction means some reactants is required, some stoichiometry calculation is required for the initiation of a fire. What is the stoichiometry? That is very important. That I can mention here is for the ignition energy. The energy is also very important. Lowest amount of energy required for the ignition. See, for varying the varying amount of this solvents, the carbon disulfide, hydrogen, different types of solvents, or having different ignition energies. That is also very much relevant for this initiation of fire also. Carbon disulfide, you can see from the 0.009 millijoule. Hydrogen gas fire is around 0.011 millijoule. Then you can see the different carbon concentrations of hydrocarbons, 0.017, 0.07, 0.14, 0.22, etc. 0.65, acetone 1.15. These are the millijoules we are presenting in the millijoules. Millijoules means how this energy we can explain. That is very important. For discharge of ignite and explosive atmosphere, there must be enough energy. The minimum ignition energies of most hydrocarbons, gases, and vapors range from 0.1 to 1 millijoule. You should carefully listen, 0.1 to 1 millijoule. The level of methane is 0.29 millijoule. A person walking across a carpeted floor can develop a potential difference large enough for a 40 millijoule discharge, more energy than it takes to ignite methane. That is also, we must be very careful. A person simply walking across a carpeted floor can generate an energy more than the required energy for a initiation of a fire. That is very important. Humans generally only sense the discharges of 0.6 millijoule or more. Then this, you have to combine all these things, because lower flammable energy, what is the significance of lower flammable energy? Very much, we must have a very clear idea about the solvents used in our industry. That you have the minimum solvent. One more thing we can see the upper flammable limit. That is also very important. In that is the percentage, the combination, stoichiometric combination. We have to go through this spark energy, how much spark energy is required in the lower flammable region and the upper flammable region. Lower flammable region, we can see a higher amount of energy, spark energy is required for initiation of a fire. For initiation of a fire. But in between a point, that point is very vulnerable. That point creates most of the time, while reaches the same point, the ignition energy will be very low, and the chance for a initiation of a fire begins from that point. That normally we are seeing that some solvent go down and all those things, we could not see any significant fire incidents in nowadays. But in some cases, we have to think where the ignition energy between the lower flammable energy and the upper flammable energy, there is a point. That point, because of this calculation, the stoichiometric and the amount of reactants, the reacting rate where it have to be decided, means that point will start the initiation of a fire. That means we must be very careful in between the lower flammable limit concentration and the upper flammable limit concentration. In between the point, very much careful. That point, the initiation of a fire is can easily happen due to any of this ignition energies, any of the external intervention, like mobile phones, battery operated things, even a small walking across the this type of carpeted floor also create an ignition energy. That all can have the chances for a fire. What happened in the storage area? There is, for temperature control, the factory has given a 3 air conditioned systems they are provided. From the start, in meanwhile, some area the electricity was disconnected and restarted that time. The starting of the compressor, the fire ignition energy initiated the fire, and the entire godown blazed into fire, and the around 50 crores of raw materials have been damaged. Like that incidents can happen on small issues of solvent vapor. This once the fuel and oxygen is present, ignition source is needed to complete the fire triangle. Hydrocarbons can be ignited two ways. When an external ignition source with sufficient energy to ignite the fuel oxygen mixture is available, that means in the form of flames, sparks, etc. And the other form is when the temperature is staged about the auto ignition temperature that I have already told, auto ignition, flash point, and fire point. These three very, very, very significant, and we shall have in some incident also we can see the one carbon disulfide accident in one of our industry. That case, what has happened is some carbon disulfide fire has some issues there. Because some carbon disulfide fire occurs, we could not identify with our normal eye like that. Some smoke detection or radioactive heat flux. CS2 flames produce negligible smoke. That like hydrogen fire. Hydrogen fire also like that. There is no smoke at all. That is relatively non-luminous also. In nature, that it shows lower emissivity and therefore results in lower radiation from flame. This is CS2 is a highly flammable. Actually, in CS2 tanks, we are supplying the water to take out the CS2 with the help of the top part. We are using the water, and we are processing with water. Then only we are CS2 is. Otherwise, it is very hazardous. Actually, it is 2% to 50. The flammable region of carbon disulfide is also very important. 2 to 50 wide the range of wide the range is there. That means the presence of air or oxygen not needed much. That is also very important. That is the last slide we have seen the carbon disulfide has a minimum ignition energy 0.009. That is millijoule. Very, very, very negligible amount of carbon disulfide. What happened in that factory? Carbon disulfide, while unloading the carbon disulfide, the flame is also like that. Different flame spans are seeing in the screen. You can see methanol, ethanol, carbon disulfide, diesel, gas. The property, the structure, etc. are different. And CS2 fire we could not identify also. That the length of the fire, the width of the fire, that also very we could not identify. Like hydrogen fire. What happened in the factory, the dummy flange of the product transfer line was removed while unloading carbon disulfide, causing carbon disulfide to spurt through the butterfly valve. Being highly inflammable liquid with a flash point at about -30 degrees Celsius. That is very important. Carbon disulfide transforms into vapor state of immediately. This is also a highly flammable solvent. Vapor could have come into contact with a hot body of a vapor cloud, causing the explosion. Subsequently, the fire engulfed. This is auto ignition temperature that reaches the auto ignition temperature. There is no need for ignition of a spark energy. That is also very important. Auto ignition temperature, the carbon disulfide fire occurs in that industry. After this is the ISO tank. We can see that this type of industry, what you have to do is a special type of this is a similar chemical unloading procedure.
Response exercise simulates a real-life incident during unloading of toluene diisocyanate, TDI, in order to test the customer's on-site emergency response systems and assess the interaction between all parties involved in dealing with the incident. This is not intended as a standalone instruction film. The customer operator and truck driver put on the required personal protective equipment, PPE, for TDI, as specified in the safety data sheet. The operator lowers the walkway to the tank container, and the driver assists the operator with connecting his safety harness to the fall protection device before he goes on top of the truck. Due to a combination of a defective gasket and unexpected pressure in the tank, the operator is splashed with TDI, falls from the vehicle, and is hurt by the impact with the gantry. The driver immediately pushes the emergency stop button, which automatically raises the sight alarm and then closes the vehicle valve to avoid any further spillage. The driver goes to decontaminate himself. The site emergency team immediately puts on the required emergency personnel protective equipment. A quick response is required as the operator has been saved from a potentially fatal fall by the fall protective system, but is still suspended from the gantry in a life-threatening position. After a quick assessment of the situation, a forklift truck is used to rescue the trapped operator. It is critical that the suspended person is rescued as quickly as possible to avoid the risk of suspension trauma. Forklift trucks should not normally be used for moving people, but it is the only option available on site to rescue the operator and prevent permanent injury.
This type of rescue system should be provided for unloading such highly flammable solvents in industries. That is very much, we must be very much careful about all these things. Otherwise, raw transfer of unloading of this highly flammable solvents like carbon disulfide will be surely an initiation of a fire hazard. And actually, incident was an unfortunate one, and actually 2 persons were died. You can see the pictures of that incident. Either the fire detectors work on the principles of smoke detection, but radiative heat flux, but these two are absent in the carbon disulfide flame. So we must be very much careful, and we must be identified the thermal imaging system like that. Any other system will be introduced, then only we can identify the initiation of a ignition. And that's so that type of there stands for poisonous emission of sulfur dioxide also. That is also toxic exposure also we have to be expect in that case. And the emergency plan, procedures for unloading and safe operating procedures, lack of sufficient training about the anticipated hazards are all required for this type of incidents. Then I am talking about some ammonia gas explosion. Ammonia gas normally it's a non-flammable gas, but actually what I have explained is it's a reaction. Reaction means some parameters are required. Ammonia gas can initiate a fire incident, or it can be in what condition we must identify how this ammonia become a fire incident. At high temperature, ammonia is a non-flammable gas, but it will ignite at a temperature of 1204 degree Fahrenheit within vapor concentration limits between 15% and 28%. The hierarchy of flammability, actually we have seen the highly flammable liquid, lesser flammable liquids, non-flammable gases. Non-flammable also gases also can create a disaster that we have to identify. In this case, this is a seafood processing in an ice factory. They are having compressor, the receiver, everything etc. is there. But suppose the temperature, this is a chain reaction. That actually the fire is a chain reaction. It's a reaction. It's a chain reaction. That means while reaction initiates, then the at high temperature around 1200 degrees, there is a chance for initiation of a fire, high temperature at fire, spark, electrical spark, or some any other some gas explosion like that, it occurs, then the chance for an occurrence of around the high temperature initiation. That means the fire initiates means the flame will continue till the end of the explosion, etc. will occur. That is the happen in ammonia gas can decompose at high temperature and forming very flammable hydrogen gas. As we know, hydrogen gas is highly flammable and we could not detect with our normal detection system. And nitrogen dioxide also will be produced along with that. In that case also, we see how this type of accidents has happened, and we must be very careful. This accident, some 2 people just died in Kannur area. Actually the initiation of fire, high temperature occurred during they are using the normally cooking operations used in the this machine room itself. Some fire has this gas was heated and the fire initiated and the explosion occurred, and then 2 persons died on the spot. This is at you can see the explosion intensity. That is the building is collapsed due to the explosion. That is a lesser flammable gas also can create a chain reaction. That is also very important. We should have a very much careful about that. This type of gases also not depending upon the flammability. The other factors also we have to consider. And multiple hidden hazards is also a major role in fueling the dangerous scenarios. That is a hidden danger, hidden hazards. That is normally in the molten solvent issues. We can see.
Center, Kansas, about 15 miles north of Wichita. After the explosion, the fire spread, igniting the contents of other storage vessels and eventually destroying the entire tank farm.
Actually, most of the solvents are not conducting, but normally they are not conducting means the solvent pumping, solvent transferring, everything. That time you have to be very careful about the static energy. Static energy initiates a fire incidents in most of the cases.
Because liquid flowing through pipes and valves generates static electricity, which can ignite flammable vapor. The tank farm supervisor connected a cable between the truck and an electrical grounding station. In addition, all the equipment involved in transporting the liquid was bonded, that is, connected together with electrical conductors and grounded. Inside the 15,000-gallon storage tank, there was a device for measuring the liquid level. A metal tape, which was grounded, was suspended from pulleys and connected to a metal float by a loose, flexible linkage assembly. This linkage presented a hidden danger during the filling of the tank. The solvent was pumped from 3 tanker trailer compartments into the tank. As the hose was switched from one compartment to another, air entered the line, creating bubbles and turbulence inside the tank. A static electrical charge built up in the non-conductive liquid. Meanwhile, the space above the liquid was filled with an explosive mixture of vapor and air. The swirling, turbulent liquid caused the float to drift and rock, creating slack in the metal tape. This allowed a gap to form intermittently in the linkage assembly, interrupting the grounding of the float. The metal float accumulated a static electrical charge. About 9 a.m., a spark from static electricity ignited the vapor-air mixture, causing a massive explosion. The blast sent the storage tank rocketing into the air. 2 more tanks quickly ruptured and released their contents into the rapidly expanding fire. As the fire raged inside the tank farm, other tanks burst and ignited, launching heavy steel tank lids 10 to 12 feet in diameter into the air. 20,000 gallons of flammable liquid were released into the spill containment area.
Valves, pipes, and other heavy steel objects were hurled off-site and into the adjoining community. One tank lid struck a mobile home about 300 feet away. A pressure valve hit a neighboring business 400 feet away.
This is also very important. We have to consider all types of such hazards, because unloading operations, we are connecting the tanker to this strips, but we are not at all considering the other equipments used inside the float and the connecting rod, etc. Also, we must be very careful. Otherwise, that will also create high hazardous situation and can initiate a fire. And this huge loss in the Barton solvent fire, we all know some huge quantity of solvents has charred into fire, and all this is a loss. And in the case also, we have to be very much careful in flammable liquid properties, flammable solvent properties, each and significance of each and every property, we must be very much careful. Otherwise, even one parameter can destroy all these or initiate all any fire situations. That in this case, the static energy initiate the fire, or the normally most of the solvents were not conducting electricity. Non-conducting solvents definitely have, we must be very much careful about earthing the or neutralizing the energy created inside the filling process. That also we must be careful.
The solvent was pumped from 3 tanker trailer compartments into the tank. As the hose was switched from one compartment to another, air entered the line, creating bubbles and turbulence inside the tank. A static electrical charge built up in the non-conductive liquid. Meanwhile, the space above the liquid was filled with an explosive.
Another special case is that the Vizag steel industry fire. That fire is how it is happened.
In
means
an accident, 16 workers, including some officers, were burnt alive following a huge explosion in the recently commissioned oxygen plant at the Vizag steel plant. This being not a lone incident, with 4 incidents reported in less than a year. Are the authorities turning a blind eye at such incidents?
Diligent workers of the Vizag steel plant did not see this coming when they arrived for work. An explosion in the oxygen unit of the plant, leading to a massive fire, killing more than 10 people. The numbers might just shoot up. But this is not the first time that a fire has claimed innocent lives at the Vizag factory. This, in fact, being the 4th such incident in less than a year, with no clear reason behind the explosion given yet. Question is, was this a case of negligence or just another accident at the factory? Bureau Report, Times Now.
this is especially we have to concern non flammable chemicals also becomes into fire, because fire is a chemical reaction. I have told reactants is present, pure reactants in the presence of air. We are substitute with oxygen, means the enrichment of oxygen lead to fire in most of the cases. That means our factory we consider to be a non-flammable unit, but we are having the storage of oxygen line or oxygen storage. In any cases, the chances for releasing that oxygen, pure oxygen into atmosphere, that means that things or substances do not burn in the normal condition, will burn immediately. And the people, this is the case of the steel industry. The one line, oxygen line, is passing through the inside the plant, and the oxygen line ruptures and the oxygen enter into the atmosphere. And then normally the oxygen level in the atmosphere is around 21%. The oxygen level shoot up to 40%. That means anything could not burn, can burn around about 27%. That means the explosion happened, and the whole system and all the people present inside the factory were burned, and that type of incident also we have to be very much careful. These are the other cases we have in the recent in Trivandrum 2018. In one, we all know the family plastic fire issue. That is, plastics we are considered to be non-flammable. That we have to be very much careful. Plastic, after reaction, it will be come to the plasma stage. Plasma stage, which is the fourth stage that matter that can easily initiate the spreads of the fire accidents and can be a very, very disaster situation. And the people, around 1,000 people are working in the factory. The entire factory has started this stage. That means the hierarchy of flammability is not an issue. In a reaction reaction, what are the parameters supporting the initiation of a fire is very important. And to avoid this, we should have a clear study of all these things, all the materials, all the properties we should have in mind. These are the fire incidents only I have mentioned. The other incidents also, toxic release incidents are there. The other exposure incidents are there. This only I have peripherally go through all these things, but detailed investigation report and detailed study report, everything is with me, and with 45 minutes I could not explain all these things. This means the hierarchy is very important. That is not only the hierarchy, because highly flammable, lesser flammable, non-flammable, all these type of substances can initiate a disaster situation, not the highly flammable chemicals. That is the case I can share to this special day of disaster, this risk reduction day. Thank you for giving me the opportunity, sir, for sharing my views about all these things.
Thank you, Siyaz. Members, any questions based on this presentation? Siyaz has given a beautiful presentation on various incidents. He has thrown light on various accidents, from solvent to steel plant, plastic, ammonia plant, lot of chemical plant, lot of incidents he has covered. Any questions based on the presentations given by him? Please come up, or please enter in the chat box. Please enter in the chat box. We will be proceeding to the next presentation. Any questions, please? Okay, we have not received any questions. So we are going to the thanks Siyad. We are going to the next presentation. 1 minute. We are going to the next presentation, that is the proactive approach to the disaster prevention through process safety management from design to operation. That is from PS Raju. I invite Mr. Raju, and Raju's presentation Mr. Nandakumar will be sharing from here. Over to Mr. Raju, please. Sri Raju, please.
Yes, yes. Hello, are you listening to me? Can you listen to me? Am I audible?
Yes, yes, audible, audible.
Oh, okay.
Audible, yeah.
Oh, fine. So I will start straight away on the topic. This is a proactive approach through PSM, starting from design to operation. Can we go to the first slide, please? Yeah, this, as we all know, disasters happen because the hazards align with the barriers through which, or whichever barriers, whatever barriers we are having, if barriers are failing and a sequence of barriers failing, aligning together will result in a hazard to become a disaster. So conceptually, when we do the design from concept onwards, the hazard assessment or analysis and identification that will have to result in the design of multiple barriers, which will prevent a disaster from happening. So the slide which shows a different type of barriers in a typical facility, industrial facility. So this can vary depending on type of facilities. This is a typical hydrocarbon facility, typically offshore. So you have multiple barriers, types of barriers. One is the structural integrity is one type of barrier. Then you have again process containment. Then you will have the ignition control. Then you have the next one is a protection system, which will prevent a hazard from becoming an incident. Once the protection system, subsequent to that, you need to have a detection system which will identify if some event has occurred. So the detection system is coming subsequent to the protection system. If a detection is done, then you need to do a shutdown. I mean, the safe shutdown of the system is to be done. So shutdown system becomes another layer which will prevent a disaster from occurring. If the shutdown system is also failing, is not able to prevent lining up of holes, then the next one is an emergency response, which we'll have to activate, which will mitigate the effect of the event. Even after that, you will need to have a life-saving systems. So different types of barriers, you can go further. Under the structural integrity system, you will have cranes. Cranes will be there. This will be a major component which can result in big hazards. Then the mooring system, the offshore system. Subsea foundation structures, because the foundation, if there is any issue with the foundation, it will result in it will start the beginning of the disaster event. It will be the top event. You have the structural integrity for the other sections of not only the subsea, the topsides or surface, or if you are on an onshore plant, the foundations of the hydrocarbon vessels or the heaters and all, these need to be designed, need to be considered upfront and designed properly with the proper risk assessment and the design philosophies involved. Subsequent to that, the next one is a process containment, which will be the mechanical, basically the mechanical integrity, mechanical structure of the equipments will be coming into picture here. And various type of systems will be there, like heat exchangers will be there, piping systems, pressure vessels, tanks, and well containment is especially for oil and gas wells. Then different types of equipments. Each of these systems which will contain a hazardous fluid will need to be treated as a process containment element, because we need to contain, in the case of any event, we need to contain the fluid which within the equipment, and should not allow it to come out in contact with the external environment, which will prevent, if we are able to contain the hazardous fluid within the containment device, then we can prevent, we will be able to prevent the disaster from taking place. Next one is the ignition control, which will be specifically applicable for ignitable, like flammable or combustible fluids will be involved, or any material will be involved. So ignition control becomes a important point, in which you have hazardous area ventilation and electrical equipments, which will be very critical. In the certified electrical equipments can avoid an ignition situation being created. Earthing and bonding is the most important, like my previous speaker was highlighting this one about, especially during the filling of trucks and carriers. Cargo tank inert gas system is another a layer or a barrier which will prevent the oxygen entry into the hazardous area, and creating a combustible mixture. Flare tip ignition is of course, because the safety flare is for most of the hydrocarbon or chemical industry. The safety flare is an important equipment which has to be maintained, so that in case of an emergency, we will be able to dispose of the fluids which are coming out. Fuel gas purge system is similar to the inert gas system for cargo tanks. Going on to the next protection system, we will have different types of protection system, which will include the deluge system or chemical injection system. Chemical injection system will prevent the corrosion of the equipments and failure of. In turn, this will help in process containment. If in many cases, if you don't have a chemical injection system, your process containment may deteriorate over time. So the chemical injection system. Collision avoidance is when the moving equipments or vessels are involved. You have deluge system, of course, is for fire protection. Then you have the power management system, which will be essential because the power, all the processes are driven by power devices. So power management can, proper power management can ensure that power availability during incidents. If a power management system is not adequate, then that itself can result in an event. Fire water pumps, fire water system, and sprinkler system. These are all protection. A detection system comes into picture when you have a fire and gas detection, H2O in conduction, condensate. Basically, this is, you can call it as a preventive layer or preventive barrier, or sometimes you may have to consider as a mitigation barrier, because some people argue that the fire and gas, the gas or fire occurs, only after that you can detect it. But especially the gas detection system is a preventive barrier, basically. It is a detection system. Next layer comes as a shutdown system, which we will have to monitor the system, which is not going beyond the limits of the design limits of the plant. Next, of course, you have the emergency response, which is communication systems and manual firefighting and evacuation routes, all these parts of the emergency response. Life saving is, of course, and you need to have intervention systems to support people who are involved in the system, like lifeboats or rescue facilities. So these sort of barriers are to be envisaged upfront during the design of the facility, and much more layers or the barriers may be required, or in some of the plants, maybe most of this, like in the onshore case, offshore will not be applicable. So proper barrier consideration at the concept stage and designing that and implementing them becomes critical. Can go to the next slide, please. Yeah. And all these barriers, normally we design or conceptualize using during the concept stage itself. And process safety management as a structured process safety management can support or help in properly identifying the barriers which are required. So you have multiple around 13 different stages or aspects of process safety management. But I will highlight few of the things as part of our talk today. The main one is a process hazard analysis, and the next one is a mechanical integrity. So mechanical integrity involves most of this, like a process containment and structural integrity. All these things will come in the mechanical integrity part. Rest of the things are at different stages. We will have to use different elements, but we will focus today on process hazard analysis. I will take only a subset of that because this is a vast topic, and we will be able to cover only a part of that today. So process hazard analysis is the prime tool for us to do a proactive planning or proactive methodology for disaster prevention or risk reduction. Can go to the next slide, please. So in the life of any plant, any chemical plant project, you have the first is a feasibility study. Then you need to do a detailed feasibility study. Then you need to do a front-end engineering, and then you of course have the EPCC, like engineering, procurement, and construction contract will be there, which will be the building of the plant, and then we'll go to the operation phase. So the feed is sometimes we will start during the detailed feasibility study itself. We will start the hazard analysis, but feed is a prime time when we go for the hazard analysis and risk studies. So this is an important phase wherein we identify your hazards, and then a risk assessment is done, and then you find what barriers we need to do, what barriers and what protections we need to incorporate in the design of the plant, so that a disaster can be prevented when the facility is under operation. So it is impossible to incorporate this most of the things once you start operation, because maybe you will have to stop production and totally revamp or redesign the plant. So upfront, providing enough resources and the time for doing the hazard analysis and risk studies is the most important. And taking shortcuts to cut costs and cut time is not at all acceptable project methodology. So this is the most important thing during the feed, whether it's a project management team or the owner, they need to give most importance for the identifying the hazards and risks, so that they are properly identified, captured, and highlighted throughout the phase, throughout the life cycle phase of this plant, which includes mainly the feed, EPCC, and operation. You can go to the next one, please. So process hazard analysis is normally done by a structured team. A team will review the hazards in the plant, and each phase of operation will have to be considered during this analysis. First, we need to identify each and every hazard. Some of the hazards may not, maybe low probability from turning into an event, but some will be. You can go back, please. So hazard identification, each and every hazard has to be identified, whether it is small or big, and the probability may be very low or high, but we need to identify all hazards in a comprehensive way. Second one is each loss event scenario, each hazard, if it is occurring, if it is turning into an event, then what will be the loss coming out of that? Normally, companies consider the health hazard, like to the person, and then the environmental hazards or environmental impact. Then it can be an asset, or the cost or economic impact will be considered. And some of the companies even consider a reputation impact. So this is difficult to quantify, but each of this different category of losses, it can be, the companies can make their own philosophy, or there are international guidelines which we can use to do the analysis and the risk ranking. Next one is evaluating of the risks and to identify where existing safeguards are not adequate. Because typically when you have a plant design, which is a conventional plant, which is the design is already tried out somewhere, then you already have the safeguards. But still you will have to review that and compare that site-specific variations you need to consider and see whether the safeguards are adequate or not. If it is a new process, of course, you need to do extensive analysis and you need to build from scratch what safeguards are required. The safeguards, I mean all these barriers which are protections at different levels. And then we need to, of course, document each stage. We'll have to document the findings, and recommendations will have to be created, and the recommendations will have to be assessed by the management. Some of the risk managements will accept the risk. Some of the risks they may not be able to accept. So we need to find a reduction of the risk methodologies and some barriers to reduce the risk. So this is the key phase wherein the management able to view what risks are involved and which one has to be accepted, which one has to be reduced, which risk has to be reduced. So PHA forms the first step for for any plant from preventing the disasters while operation. Next, please. So for any process plant, we have multiple layers of protections. The lowest is the process design. The design itself can be an inherently safe design. Then you cannot design all the designs as an inherently safe design. Obviously, hazards will be there and the risks can be varying. So once the process is there, you need to have the process control to limit the process to within the safe operating limits. So the process control devices are essentially you need to incorporate to limit the process from varying from into unsafe domains. So the safe process has to be controlled. Say safety as well as the, you can go back please. The safe operation as well as the original intention of the process, the ultimate process target objective is to create some product. That also is there as part of the process control objectives. The next layer will be alarm, which will show that the process is deviating towards an unsafe limit or it's going beyond the safe operating limits. So alarms will be required where the operator can intervene and bring the process back to the safe condition or the desired condition. Above alarm, you will have a trip or protection or safeguard systems. Typically, you will have the safety instrumented systems which will trip or shut down the process before an event or an undecided event takes place. So on top of the alarm, you will have the trip systems or shutdown systems or safeguard system, whatever we call it different ways. Some people call it instrumented protective function. Some people call it safety instrumented functions. On top of that, you have the incident is happening like a pressure exceeding exceeding the safe limit of a process containment device or equipment. So an incident is reaching when you are exceeding all these limits. So you need to have the active protection measures like relief valves and rupture discs, which will channelize the energy or chemical or fluid into a safe disposal route. So active protection measures will be there, and on top of that, if still we are not able to bring back the process, then the loss of containment will occur and you need to go to the passive protection functions like dike walls or separations from the community or external environment. On top of that comes the planned emergency response, and then comes the community emergency response. So these are multiple layers of protections which need to prevent, which are essential to prevent our process from going to a disaster situation. Next, please. So this is another form of representation which moving from the top to the lower, we have the initial risk without reduction measures. Then you have the process. Process has to be inherently safe and with a stable operation. That is another layer. The third layer is basic process control, which will go back, yeah. And the next one will be the pre-alarms or alarm systems. The next layer will be the instrumented protective function or safety instrument functions. You call it IPF or SIF in different regions of the world. And then next one is the mechanical devices or active measures. Now Next one will be the other means. It will include the passive measures and next layers like community emergency responses. Next one, please. So again, layers we have represented here, like the internal top, most inside one is the systems and procedures, and you have the basic process control, then critical alarms or an operator intervention. Next one is a safety interlock or safety instrumented systems. So next one, mechanical relief and the plant community emergency response. So this is always reiterated because you have multiple layers possible, and depending on the effectiveness of the inside layer, we may not have to go to the outer layer, so that you are far removed from the disaster. So as we move outward, we reach the disaster situation. Next, please. So this one is the most important one after the design, after the process design, which is a basic one, which we try to design an inherently safe process. And outside that, the process control will be also part of the process design. But subsequent to that, when the process starts varying towards an unsafe condition, the first layer of protection is our alarm for the plant. And we have the bottom green one is a normal condition. You have the alarm condition where the operator has to he has to be notified about the alarm and take appropriate action. So operator should have adequate time to react. So the process design is the process reaction time, or the time to take an action. If the operator takes an action and that action is actually resulting in a change in the field, there may be a time delay between that. So that much time you need to give for alarm to be coming in advance. So if you don't have adequate time for the operator to act and the change has to take place in the plant, then this alarm is not effective. So you need to have adequate time for the warning. And then if still you are not able to bring back the process, then you go to the unsafe condition and other automatic systems will have to involve. So it is better not to go to that level, and operator himself will bring the process, and that is the easiest at that time. So this alarms designing is one important proactive measure to prevent our process to go to disaster condition. Next, please. So this is a typical alarm representation where you have a target. A target operating point is there. That is it's shown as a ellipse. So around that you have a normal operating, and then outside that you have an upset. So when you go towards the upset condition, operator has to monitor and intervene and bring it back to the normal condition. That is the purpose of the alarms. Next, please. So for alarms, starting from the feed stage or feed or EPCC, both stages, you need to have alarm management process, which is required for any plant, because unless you have a good alarm system, the operator may be flooded with so many alarms, and so each alarm will become it's difficult to manage the alarms, and too many alarms will make the operator complacent. He will ignore all alarms. So you need to have only the alarms which are required, and those are to be coming at with adequate time to react. So alarm you call it alarm rationalization. First of all, you need to eliminate unnecessary alarms and provide the alarms which are required. And then you need to do even the set points will have to be adequately changed so that you don't need to get an alarm too late. So alarm management, you need to have a philosophy. I will briefly go through this structure. Like you need to have a policy or philosophy of the alarm, and then you need to identify each alarm. It's just like a hazard identification and hazard analysis. You need to identify all alarms in the plant, and a process called a rationalization, in which you take and evaluate each alarm whether it is really required, or it is what is the risk of each alarm, what is the priority of each alarm, it's a low priority or high priority, or something may be not required. And once the alarm priorities are identified, then you need to also have the time. In addition to the priority, you need to put the time which is available for reacting to the alarm also has to be considered. And then once you rationalize, then the design in the EPCC or the feed or EPCC phase, people will have to design the alarm and implement it. Once it's put into implementation and it's constructed, then you need to, while operating, it need to do a continuous performance monitoring of whether how many alarms are coming in a plant, whether the operator is able to handle this many alarms. Maybe if too many alarms are required and you don't have enough operator, then it becomes a problem. You may have to add more number of operators, because this is a highly unstable plant. Then you need to have more operators, and they have to be trained also, obviously. So this process goes on right from feed stage. This starts and it goes continuously. Even during the operation, periodic review and improvement is required for the alarms, because alarms becomes the most important tool for us to bring back or keep the process in a safe condition. Next, please. So once the alarms are enabled, or the operator is not getting this alarm notification, and it has just passed through that phase, and then you are on a higher level, higher disturbance level, then the safety instrumented system is automatic, which doesn't need an operator to react, that has to come into picture. So in the safety instrumented system, what we are doing is we have an unacceptable risk region for the process plant. Then we have an acceptable region of the risk, and then we have a tolerable region. So the idea is all processes has to move from unacceptable risk region to acceptable region, and in between you have a tolerable region. So initially you will have an unknown risk. Then you need to identify, when you identify all the risks, you will see the inherent risks, and then you need to do a risk analysis, and the risk analysis and apply some process improvement, which is the red one in the middle. That step, you can go back, please. That the process improvements will result in a revised inherent risk. Then you identify what is available safeguards. With available safeguards, you will reduce the risk further down, and the residual risk will be there. Then you need to do whether any gap is there in the risk to bring into the acceptable region or tolerable region. Using this, identifying available SAS safeguards, and then you need to allocate risk. Each risk has to be allocated to some sort of new safeguard. So once you identify the safeguards, and then you identify what sort of performance requirements are required there for each safeguards. So each safeguard will have to be given a particular reliability value. It's not like you have multiple reliability levels. So if the low risk has to be handled, then you have low integrity level required for the safeguard, like SIL 1, SIL 2, SIL 3, SIL 4 is. This is the way the international standards categorize the integrity level, or as a reliability or integrity, you can call it. The how much it is guaranteed to take it's guaranteed to function. That is, if it's a SIL 4 device, is guaranteed to function much more than a SIL 1 device. So you need to have multiple SIL devices. And then this is a safety instrumented system has a life cycle, which starting from the HACCP or LOPA or faulty, multiple methods are there. You need to identify the risks, and you need to go through what type of equipments or what reliability devices are to be built into the plant. So that is one part of the right from the original design till the operation. You need to have a process of building or designing the safeguards for the plant, which is the next layer of the alarms. Can go to the next one, please. So these SIL is a safety integrity limit. So the safety instrumentation will have a life cycle which will start from the process hazard analysis on the top, and then the allocation, design, verification, and then implementation and operation. You have multiple stages which will start much before the plant is constructed. Before the construction, the design stage itself, you need to specify what type of safeguards are required. So there is a whole domain of activities. Different trained people with certification, they have to do studies, analysis, and recommend what performance standards are required for each equipment, which is involved in the safeguarding systems. Can go to the next one, please. So the safeguard system, that particular two slides which I limit is a big topic, because we need to do a lot on that to have a good system implemented. So that is it's a preventive layer basically, which will prevent a hazard from becoming a disaster. So you have again after the preventive layer, you have a fire and gas detection mapping, which is a fire and gas detection system is typical for most of the plants. You can go back, please. So this system, fire and gas detection, conventionally it used to be implemented in a prescription-based method. Like they will say that, oh, this particular vessel, which the tanker, you can have this two detectors on both sides or on top of it. So that sort of a design was, it used to be there as a prescription. They will prescribe, okay, what is required, what is required. And it has now changed to a risk-based or analysis-based method, where you have to do a mapping. Please go back. Previous slides. The mapping is, fire and gas detection mapping is critical to ensure that the detection system is properly placed, properly designed, so that it is able to detect the hazards or the gas leaks or fires, and whether the positioning is right, how many numbers of detectors are required, from which angle they should be pointing. So normally nowadays a 3D based software, a complex software is required, which will involve flow dynamics of the plant, in which each point, if you have a leaks, can you go back, please? So depending on the leaks and the leak points and the prevailing wind directions, wind conditions, All these things will be taken into consideration, and the 3D modeling software can map or it can have the model of the plant in which the leaks, where all is going to spread, the gas leak, or if the fire is there, how it's going to be developing in the plant. And then depending on that, each plant peculiarity, you may have to position the gas detectors or toxic gas detectors in different locations. This mapping is an important thing which can optimize. You don't have to overbuild the plant. In prescriptive methods, sometimes you may have to put too many detectors, or it will be too less detectors. So this one, data collection and hazard identification, is the first stage. And the next one is you need to have a performance target setting. Each coverage of device, depending on the plant, what type of hydrocarbon is there. Based on that, you need to put the coverage target and equipment, what type of equipments are there, high pressure, low pressure, and what type of fluid is contained. So and subsequent to that, you need to have a software mapping, and that mapping is a 3D. Nowadays 3D mapping is widely available, and using the mapping, then the place detectors in the layout of the plant, and then a report will be generated which say that whether it is sufficient or not, each detector, or it will recommend us, and you need to play around with that software and move the detectors into different locations and see whether it is resulting in the adequate coverage of the fire and gas detectors in the plant. And this becomes an important thing in finding the fires or gas leaks in sufficient time, so that it will not develop into disaster situation. So fire and gas mapping is the third layer, and subsequent to that, you have the passive or active systems, which will be dikes or sprinkler system, firefighting systems, all will be there. I am not going to talk about that because it is again a different domain. So these are regarding the conventionally, these are the disaster prevention methods, but the current times we need to consider one more layer, which has become very critical. Now we can go to the next slide, which is the cyber security of all these controls. Whichever controls you have, whether it is for the detection or the alarms or process control or safeguarding, or even for your emergency response, all are using computer systems. And cyber security is different. It's an essential level it has become, because so many things are happening in the in the web nowadays, and you can have your equipment nicely designed or well designed, well implemented systems can fail if we are not considering this aspect. So cyber security of industrial controls, that has to be a main topic when the design is evaluated. So you have maybe different type of threats are there for any plant, whether it is public services like water supply units can go back, the water supply units or power distribution or chemical plant. These elements can be there everywhere. For example, crackers break into computers for profit, and they lock it, and they lock the passwords, the hard disks or the data, and ask for the money. So these sort of hackers are there. Then you have terrorists who are deliberately attack systems for creating damages into systems. And then you have some places you can have insiders due to grudges or some revenge or something. Some people who are leaving some companies can use their knowledge of the system to create some havoc or problems to their earlier employers. This has happened in many places. And then next one, of course, is the sort of a warfare, which is hostile countries, which is now is since the Ukraine war has started, you are seeing between Russia, Ukraine, and Iran, China. You have seen this happening, North Korea, and all. A lot of things are happening. Even in India was affected by some North Korean operators. Even though we are not having any direct confrontation with North Korea, still we were affected by some of the actions by the North Korea and the cyber warfare. So this one is another consideration for is a proactive approach we need to do. Which one? Next one we will just explain what type of problems, cyber threats are there. It can be like Trojans or viruses or worms. These can be coming in different modes. It can enter the system, whether it's a distributed system like in our case, even the water authority and electricity boards and all need to be protected, because we never know, advertently or inadvertently, by purpose or without knowledge, some virus can come in and can create problems and damages. It is a big topic. We have a lot of statistics to say what damages, what issues were happening around the world. In Saudi Arabia, when I was there in Qatar, in Saudi Arabia, I think 15,000 computers were affected and had to be replaced because a deliberate virus was introduced by Iran into Saudi Aramco systems. So this is not is an old story. 10 years back. So this is increase in number of attacks on recent times. We can go to the next one, please. So this one is a cyber security management system, which anybody, any organization which utilizes computerized systems will have to have a system where you prevent, you consider the risk. Again, the risk PHA is involved there. You need to consider the threats and the vulnerabilities and quantify the risk. And based on the risk, you need to put preventive layers so that an external agent, external threat cannot come into the system and result in a disaster. So there is a standard, industrial standard, which is in the IEC standard, International Electrotechnical Commission, standard 62443, is a standard which specifies how to build a system for proper cybersecurity, which has, if I say the second column, I will briefly mention that you need to have personal security. Each person who is involved in the plant has to be vetted properly, and then physical and environmental security, so that anybody who is not involved in the facility is not having access to the facility. So you need to have a proper physical access controls. Network segmentation means you need to segment or put the systems into different segments so that it's not a single segment and one place you enter and everywhere is gone. So segmentation is important, and then access control. So access control itself having 3 different parts, and access control to the entry into the system can be controlled so that the system is protected. Then again, there are additional layers. All these can help us into preventing a cyber threat resulting in a disaster situation. So I think I briefly covered some of the process safety management issues plus the cyber security management. It can affect the process safety management. And all these systems, all these 4 different elements will have to be thought from the beginning of the design of the plant, and it has to be continued improvement through analysis and review, and improvement has to be done. for the throughout the life of the plant. So I will conclude as this is a brief talk about how we can, which topics we will have to consider while thinking the disaster prevention for process facilities. Thank you very much for giving me the time and listening to me. And any questions, I can take maybe a couple of minutes.
Hello, dear participants. Mr. Raju has given a beautiful presentation on proactive approach to disaster prevention through process safety management from design to operation. Mr. Raju, I think you will be remembering me. I was also there in BPCL Kochi refinery for the last 36 years and superannuated in June 2020. I think you will be remembering me. I was there in manufacturing project and in safety. Okay. Yeah. Okay. My dear participants, now we had completed the second presentation. So I request the participants, any questions they can raise through the chat box, please. At the earliest. Yeah.
I at this point I can just add, we had a detailed one-day class in the NSC sometime back for all our engineers in different plants. So I think we should repeat it for more
surely,
people.
sir. Yeah, surely, sir. Surely we can plan the same subject in a detailed manner. We will come to you, sir. Okay.
I think that will be
Madhuri, okay. Sir, we have received in the chat box a lot of excellent session. I think Srimati Madhuri, she's from Goa. She has participated and she has given her opinion. Excellent session, and that's all. We will be going to the next session. Sir, she is asking about, is there a list of antidotes to all chemicals as per MSDS? I think whether you can answer or it is to Siad.
No, it should be to Siad. I think.
Siad. I think Siad will be here. Siad. He's not there. Eh? Yeah. Mr. Siad, there is one question has come from Mrs. Madhuri. She has asked a question, is there a list of antidotes to all chemicals as per MSDS? Whether is it available in the MSDS? Or MSDS?
Not available in MSDS. Actually, symptomatic treatment is there for the chemicals. Actually, the treatment side is occupational health, occupational medicine side. Actually, symptomatic treatment, some suffocation occurs like that. The treatment for relieving the symptoms like that, medicines are providing. Systematic, what are the symptoms? Symptom-based treatment is giving. No specific antidotes is prescribed in it. That will be decided by the doctors. Actually, not specified anywhere.
Okay. And also Siad, there is a new system coming up. I think the globally harmonized system in place of MSDS. I think that has not come up in India.
Yeah, we can refer in the Cameo, and so many softwares are available. But in anyone not mentioning the proper treatment side, not mentioning occupational medicine, not actually not in practice now.
Okay. And there is one question from Mr. Vipin Das. How will you differentiate a BPCS and SIS? I think this question is to Raju.
Yeah. This is a good question. The BPCS normally it's a basic process control. Its purpose is to ensure that the process is running in a desirable or to produce the equipment. And the purpose of the BPCS, the objective is to keep the process running. And SIS is actually to bring the process to a safe shutdown. So it's basically the BPCS and the SIS behaves in opposite ways. One is to keep the process running. The other one is to shut down the process. And essentially the elements, like you will have three elements for both systems. One is a sensor in the field. The other one is a controller in the control system, and then the final element which will control the process. So these three elements, the three devices will be there for both process control, basic process control, as well as the safeguard safety instrumented system will be there. But the BPCS system will be normally the reliability is not as good as the safety instrumented system. In the safety instrumented system, we need to have a performance measure which normally is called as a probability of failure on demand. When a demand comes, is how probably it is to fail. So we need to have a failure probability should be very less. That is where the SIL levels are coming into picture. For BPCS, there is no SIL levels. Is it clear?
Okay, Sri Raju. Okay, now we are going to the next presentation. Over to Jayakumar will be giving an introduction.
Yeah, Mr. Jayakumar, AGM retired from FACT, would introduce the speaker, Mr. Dilip Madhavan, and then from there to Dilip. Over to you, sir.
Thank you, sir. Today we are happy to have Sri Dilip Madhavan for the third presentation in our session. And is presently employed as Senior Manager in the Fire and Safety Department of LNG, Petronet LNG Kochi Terminal. He has pursued the BTech in Safety and Fire Engineering from the Cochin University of Science and Technology and holds NABOSH and IOSH certificates. He has undergone lead auditor training in OSHA's 18001 and was a graduate member of the Institute of Fire Engineers, UK. He has an industrial experience of over 15 years in manufacturing and gas sectors with extended expertise in the field of fire safety management systems. In the course of his career, he witnessed and was involved in major rescue operations in incidents such as the Balco chimney collapse that happened in 2009, Kollam explosives blast in 2016, hot metal spills, spontaneous combustion of coal and electrical fires. His current responsibilities include ensuring safety in LNG terminal through risk assessments, fire prevention inspections, training, emergency response, and continual improvement of safety and fire safety management system. I would like to invite Sri Dilip Madhavan for the presentation. Over to you, sir. Thank you, please.
Thank you, Jayakumar sir. I hope I'm audible and my screen is visible.
Yeah, very much.
Thank you.
You can make it in presentation. Yeah.
Yeah. Thank you, sir. So warm welcome to all the participants today, and it's a pleasure to be here to discuss something or share some experience rather on off-site emergency drills with the two eminent speakers who have already contributed nicely on this occasion of industrial disaster risk reduction. My job is a little easy. I can take some references from the previous sessions also. Quite contrary to the previous sessions, our session will talk more about an experience sharing on offsite emergency mock drill, which was recently conducted in LNG terminal in Kochi. And to make the session interesting, I have some facts and figures which I believe could be useful for you in some future. Yeah. So the contents for the day, we have some information followed by guidelines on conductance of offsite drill and an industrial case study. I would request the participants to stop me wherever they feel like and try to make the session interactive as possible. We can also take up the questions after the session, but in between, if you can stop, then the flow can be continued. So I would request the audience to interrupt or engage whenever they feel like. Thank you. Let's quickly move on to some facts. We have all heard about the Sendai framework by the UN. Okay, so that has outlined 7 global targets, very ambitious targets by 2030. Hopefully, we can achieve all or some of them. So the targets are categorized into 7, and out of which the target number G talks about increasing the availability and access to multi-hazard early warning systems. So this is the focus for this year's theme or this year's industrial disaster risk reduction. So to increase the availability and access to multi-hazard early warning systems. So you might have seen this in the posters and the banners and the themes which have been published world over. The theme for the day. We have the topic on offsite emergency. So with a small disclaimer, let us start. We'll not be talking anything about on-site emergencies. We'll talk mostly on offsite emergencies only. What is an offsite emergency? We all know. It is also called a level 3 emergency. Level 1 and level 2 are known to be on-site. Level 2 can escalate into a level 3. We'll talk more on this in the coming slides. So an offsite emergency, as you all know, is an emergency that can take place in the installation, and the effects of the emergency can extend beyond the boundary wall of the terminal or the industry. The snowballing or the escalation of the event into a major disaster and the subsequent effects on the life and property can be mitigated if there is a offsite emergency plan available with the concerned district authorities. Which means a good district emergency plan or an offsite emergency plan is very important to as important as an on-site emergency plan for an industry. So hopefully at least few of us have gone through the state disaster management plan, and also the industries and the people in Kochi, if they can go through the district emergency response plan or the disaster management plan for Ernakulam district, which was made in 2015, I believe. These are all very good plans, very vehemently prepared and exhaustively prepared. That can throw some insight about what kind of emergencies can happen in the city, how to mitigate that, what are the emergency contact numbers, everything is well defined. What is the offsite plan? There are different terms by which it is defined. Offsite emergency plan can also be called a disaster management plan, DM plan, an emergency response plan. Here in our industry, we call it an ERDMP, emergency response and disaster management plan. So all one and the same. It is a plan to control and mitigate the effects of the incidents in above ground installation or underground installations or even road transportation. So to prepare this plan, we need extensive data. And the plan is not prepared by an industry alone. It has to be prepared by the district authority, for which the information has to be given by the respective industries. Aims of a disaster management plan: to safeguard and preserve lives, property, and environment, to contain and control the incident, and to restore normalcy. So you might have heard these terms in some other context also. I can recollect anyway. So I'm just mentioning the aims of a first aider just to relate it. Who have undergone the certified first aider course, you might have learned what is the aims of a first aider, to preserve life, to prevent harm, and to promote recovery. You can relate this. Say the aims of a disaster management plan is to safeguard lives, to contain the incident, and to restore normalcy. Just for theoretical. Okay, so what are the statutory regulations on disaster management in India? We have broadly around 15 acts or codes or rules which mentions something on disaster management. Many of these are already known to you: the National Disaster Management Act, State DM Policy, Chemical Action. I'm not going to read out everything, it's self-explanatory. The important part is the district administration shall coordinate and monitor the implementation of the national policy, state policy, national plan, and the state plan, and even the district plan. So here district administration is the whole and sole responsible agency for implementation of all these acts and rules. Just to continue, an on-site emergency plan is mentioned in a couple of law, like the Rule 12 of Kerala Factories. There's a rule called Kerala Factories Major Accident Hazard Control Rules 2005, wherein it mentions that every occupier should prepare an on-site emergency plan. And also you all know about Rule 13 of MSIHC rules, where the occupier has to prepare an updated on-site plan containing the details. Okay. So there are two rules which specifically mentions about on-site plan. And regarding offsite, the Rule 9 of Chemical Accident Rules 1996 and also the Rule 14 of MSIHC rules mandate about the offsite emergency plan. So the offsite emergency drill, the frequency of conductance of an offsite emergency drill is annual, once in a year. So the district authority will decide on which industry to select for the drill, and it has to be executed accordingly. It's not that each industry has to conduct an offsite drill every year. No, that is not possible. It has to be decided by the district authority. Only thing what an industry can do is to keep requesting the district authorities to carry out a drill in their respective area of operation. Now, the major chemical industries in Ernakulam, as per data in 2015, it is around 23 now. You can see all these industries are MAH installations, major accident hazard installation. You know what is a major accident hazard installation? It has to be notified under the Schedule 2 and 3 of the MSIHC rules. So if you see FACT has 1, 2, 3, 4 units, and even BPCL is also having quite a number of MAH units in the district. And even in Petronet LNG, where I'm from, we are also a major chemical industry in Ernakulam. So MAH industry is considered to be a more risky handling industry, industry which handles more inventory, and there the possibility of an offsite emergency cannot be ruled out. So the focus of chemical emergencies in Kochi is mostly for the attention is more towards these kind of industries. Not that other industry cannot have the potential of an offsite emergency, but our focus is these. What are the offsite data required for hazard, vulnerability, and risk assessment? So as I explained, there is a huge exhaustive data which is required, unlike on-site emergency plan. For an off-site plan preparation, we need the district profile, the area boundaries, administrative divisions, geography, topography, even the meteorological data, the demography, population, agricultural productivity, animal husbandry, education, festivals. So these all will contribute towards a better preparation of a better off-site emergency plan. The hazard profile, the natural hazard profile, which seismic zone is Kochi into, what is the wave height for a tsunami in this part of the world? Is there any epidemic or pest attack prone areas? Are there technologically triggered points in the hazard profile? So all these are very important. List of chemical industries, inventories, emergency communication flow chart, reconstruction. So some of these are duplicating with the on-site plan also. We can see some data for preparation of offsite plan is very exhaustive. So I come from an industry where I've joined as a graduate engineer trainee in my initial part of my career, which is Bharat Aluminium Company. And I had the bad fortune, I would say, to attend to one of the worst industrial disasters, which is chimney collapse, which happened in Balco. So very few reports are available in Google. At that time, it was even reported in the BBC and the CNN. This happened in 2009, in September sometime, and you could see some images of the chimney, which was under construction around 250 meters in height for a power plant, for a new upcoming power plant in the complex. So very bad days were around 6 to 7 days. We were all in rotating shifts doing some rescue operation and some rehabilitation operation. So the point is whether this emergency is on-site or off-site. It's a pretty simple question for all the safety professionals. Yes, this is within the boundary premises and considered to be an on-site emergency. But then what happened during this emergency is there was multiple casualty losses. Even more than around 43 people died and more than 100 injured during this collapse. And there was absolutely no possibility of the on-site team to attend to this emergency because of the public riot or the mob riot, you can say, at that time. Because basically what happened is the Biharis and the North Indian laborers who actually suffered fatality from these from this collapse, their family and their friends and colleagues, everyone started protesting and putting fires into the nearby buildings. Did not allow the ambulance to come to the spot, threw stones and beat up all the people in the plant. The emergency responders could actually not start the rescue operations till around 3 to 3.5 hours after this incident has happened. So then finally what happened was the government authorities in the presence of district collector came out with a plan. They came in with all their equipments and tools and the concrete cutters, breakers, JCBs, hydras, and started the rescue operations. And we were like extending the support to them. So these kind of experiences also have a big learning and impact, because now that we know about the mock drills and the on-site emergency, even how many of us conduct mock drills on a scenario of building collapse? No, it is actually not possible to simulate this incident, right? You can have smoke generators to generate smoke and then create an incident scenario, or you can, I've seen industries where they actually put up flame, a small flame, and then do a mock drill, which makes the entire scenario more interesting. But for a structural collapse, we have to imagine what exactly happened and then accordingly act. And how many of us do that? It's a big question. Also, if such a thing happens, how many of us consider about a public riot or a mob attack during such times? Because the psychological differences among the people are very important. How people behave during an emergency, what will be their psychology is all we don't know. So those things also have to be kept in mind, and the team has to prepare for all kinds of response activities. That is the only takeaway which I wanted to tell during the incident. We all know about some databases on disasters. Just to make the session interesting, you can refer the EMDAT, the E-Center for Research on Epidemiology on Disasters, CRED. And also the second one, Asian Disaster Reduction Center, ADRC. These two databases give interesting facts and figures about these disasters which occur in Asian countries and India. And there is NatCat, Sigma. Also in India, there is Ministry of Statistics and Program Implementation who brings out the statistics, and many, many more. You can see US has their own database, the Philippines, Hong Kong. So relevant to our country, we can refer ADRC, the Ministry of Statistics and Program Implementation India, EMDAT. Those give credible data on the disasters which have occurred in this part of the world. I was just going through the State Disaster Management Authority website the other day, and this website is also pretty interesting. So I would request every one of you to go through this site also, which gives comprehensive data on disasters. Now, there are early warning detection data and so many hierarchies, and the emergency contact numbers have all been given, and the warning systems are all been mentioned. So there's a beautiful website by the KSDMA also, which can act as a database for the disaster management. So with this, we end the first part of the information. I've tried to bog you with many informations. A few of them would be takeaways, and few you can, if you want to refer to the presentation, you can get it from the National Safety Council later on also. Free to, I'm open to sharing the presentation. So our focus area for today is the guidelines on conductance of offsite mock drill and the industry case study. So quickly going through the guidelines. See, these are several drills conducted in the city and in the state, the offsite drills. Petronet LNG conducted a drill on January 20th of 2020, and even Cochin International Airport, even the district jail has conducted a mock drill. There's a chemical drill conducted in 2017. Railways have conducted a disaster management drill. So these keep happening, and very unfortunately, very few newspaper clippings and reports are generated, and very less information is passed on to the residents. The public rarely know about what has happened and what to learn, what are the takeaways from this. So this is some area where focus has to be given by the government. Of course, it is not in our hands. But then whenever a drill is happening, it is always better to bring out reports. There are countries and industries even in the West where they share even the near misses and the incidents. They don't care about the Dubai Aluminium and even Aramco. You have to go on through their websites and you can see the incidents which have happened, and they openly share. So the sharing culture has to improve in the state as well, in the country. Before moving forward, let us quickly go through key abbreviations. You may have heard some of these. DEOC stands for District Emergency Operations Center. ECC stands for Emergency Control Center. LECC stands for Local Emergency Control Center. IRS stands for Incident Response Team. So out of which DEOC and LECC are not directly inside the industry. Those are set up by the district authorities. So pre-planning is always important for a off-site emergency mock drill, even for on-site drill also. So the first pre-planning happens through a coordinated conference. Normally it is chaired by the Deputy Collector Disaster Management for the city of Kochi. And it is normally attended by the government officials like the police, fire services, FNB, hazardous industries, etc. So the key outline or the objective of the conference is to conduct the mock exercise to spread out the scope of the exercise and select the industry, decide the date, identify who all have to involve, and which media to cover and all those things. So this happens in the pre-planning. After pre-planning, what happens is a tabletop exercise. So many of our industries, I'm sure, is conducting tabletop mock drill exercises also. We have competitions on tabletop mock drill conducted by NSC last year. And even industries like FACT, I personally know about industries who have been doing excellent tabletop exercises. Very important, because on a tabletop exercise, we actually simulate the scenario, not in the field, but across the table. And then each of the role member, emergency response member, points out what is their role, and they actually enact it in terms of, they mimic what they're going to do in such an emergency situation. These are very important. Once the tabletop is completed, then we go for the actual drill. So the date is fixed. Now, some more guidelines. There is emergency siren code for each industry, I'm sure. Not only for on-site, but for off-site emergency also. So, but if you refer PNGRB, the Petroleum and Natural Gas Regulatory Board, which actually governs all the hydrocarbon or oil and gas industries across the country, we have actually 3 levels of siren code. For level 1 on-site emergency, the code can be decided by the entity or the industry, depending upon the size and complexity. So I can decide my emergency level 1 siren. That is what PNGRB says. But when you go to level 2, PNGRB guidelines are very clear. You have to have a wailing sound or up and down siren for 2 minutes duration for level 2. Level 2 is what? When an emergency may require a mutual aid support, or maybe like the state fire and rescue team and other nearby industries for controlling it, and it can escalate anytime to level 3. So level 2 emergency is more critical, as the name suggests. For a level 3, which is an off-site emergency, the siren code is a little different. We have a wailing sound up and down for 2 minutes, followed by a 1 minute break. And then again wailing sound for 2 minutes, 1 minute of a break, and then final 2 minute up and down siren. So the total duration of an offsite siren is 8 minutes, as you can see. So very clear. Emergency level 1 is decided by the entity. Level 2 is up and down siren for 2 minutes, and level 3 is up and down siren for 2 minutes, followed by breaks. All clear siren is the common. It is a straight run siren for 2 minutes continuously. And even the test siren is also a straight run siren for 2 minutes. Now, PNGRB says that emergency siren has to be tested once in a week. So this practice in Petronet we follow every Saturday at 10 o'clock. We give an announcement, public announcement, and then we test the siren with a test run. And of course, the emergency siren is blown during the emergency drills, which happens once in 3 months. So unlike MSIHC, for PNGRB outlines or guides that the emergency response drill or mock drill has to be conducted once in 3 months. Now, there is also something called an emergency control center. We all know about our own ECC. After the session or whenever time permits, I would request all of you to go back and review what we have in our ECC. It is more often not audited or inspected. And yeah, of course, there are industries which do a comprehensive checkup of ECC, but these are areas which loses focus. Okay. Now, ECC, the guidelines, overall universal guidelines say that ECC should have a backup arrangement. So in case you have a single ECC, you always have to look at a change of location in case the emergency escalates to an offsite. So accordingly, have ECC1 or ECC2. Okay. It should be located, ECC should be located away from the potential hazards and provide maximum safety, and preferably in an area like your reception or the gate area, main gate area with a conference room or some kind of a arrangement, which is far away from the unit. That is preferable. ECC has to be of non-combustible building, either of steel frame of RCC, and at least 2 exits and adequate ventilations have to be provided. And it has to be equipped with so many equipment. So there is no standard guidelines for what all have to be there in the ECC, but then out of experience and from referring a few standards and codes, we can always arrive at the best ECC possible. So what we have done in Petronet, I've just mentioned, we have emergency response plan copies, maps and diagrams, which always every ECC would have. There are aerial photographs and maps, names, addresses, and telephone numbers of the employees, and there are even the blood groups, dedicated LAN and fax line, two-way radio, emergency lights, even facilities for recording the sequence of events. I don't know what many industries follow. There is someone called a scribe or someone who actually records the incident time to time. An incident recorder is there. We follow a system where we have a recorder, a tape recorder, and we switch it on and keep it in the ECC during a drill or an actual emergency, and all the communications are captured in the tape recorder. Okay, of course, a dedicated computer with LAN, internet, and soft copies of all the SOPs, plan diagrams, P&IDs. These are all preferable to be kept inside the ECC. A sample ECC checklist is mentioned here. This is what we follow here. It is categorized into 3: fixed arrangements, emergency equipment, and the documents required. Now, I would not say this is the best ECC checklist available ever. There may be even better things available, but we have tried to improve upon this checklist with each audit and each experience sharing. I can share a copy of this checklist for whoever is required. Okay. Some of the infrastructure in emergency control center, the dedicated hotlines, the map, the big drawing and layout of the plant with the emergency systems, the contact numbers, PPE cupboard, safety equipments, and the documents. So we are all familiar with these terms: prevention, mitigation, preparedness, response, relief, reconstruction. So all these terms are very familiar with us, right, as safety professionals. But the challenge is to remember these challenges. So close proximity of hazardous storage and process to compound walls is what is to be considered during an offsite emergency. So whenever you prepare an offsite scenario, always consider the compound wall boundaries. And also there is whoever follows OISD, there is a very good standard for layout of oil and gas installations. You can refer OISD 118. Even other industries can also refer OISD 118 when they set up a new terminal or an industry, or whenever they do any management of change or add on any equipment in their industry. OISD 118 gives very good safe distances to be followed during such changes. Press and media, the fake news, panic triggers are something to be very much considered. You know, the kind of media attacks and the media hypes which happens these days in the social media. So always have a single point contact to interact with the media. Do not allow any of your employees or contractors to directly interact with the media in case something happens. So all the minor details which goes out to the media may not be projected rightly in front of the public. So have single person like your HR person or the liaison officer to contact the media. Community response is very important. So if you want a responsive community around your surrounding, then you need to do very good community engagement programs like CSR programs and engage with the community. Unfortunately, many of the industries find challenge or difficulty in this because the moment you go out to the community, then there are a lot of demands from the community. They have a lot of challenges, rehabilitation issues, job issues. They expect many things from the industry. So have a good team or a PR team and the CSR team to liaison with the community so that in case of an emergency, you have them along with you to support you. Infrequent mock drill rehearsals are another challenge which is normally faced. So have frequent drills, even though MSI factory rules have specific periodicity of drills. So you can even bring down the frequency. For example, we conduct fire drills every month. Maybe too less a frequency, but then it has reaped very good results for us. A fire drill every month is not required as per any of the standard. So we can go with our own frequency, a lesser frequency than what is mentioned as per the statutes. Communication overload is another issue which has to be checked up to. For example, we follow a system of different channels for security, fire, and operations. So accordingly, the communications is not overloaded. But even though you can see the walkie-talkies being constantly buzzing with all the communications. And so during an emergency, how to communicate, who to communicate, and what not to communicate, and all should be very clear. And the training and awareness and sensitization on the same can be given to the employees. The last part of the presentation focuses on the specific offsite emergency drill, which was conducted in Petronet LNG in 2020. We'll directly go into that. Some photographs of the offsite emergency drill. The scenario was natural gas leakage from the last point of the terminal, which is our metering area. One of the valve gland leaked and heavy natural gas release occurred from the send out line. That was the scenario. And the scenario was such that there was only leak, which went even outside the boundary wall. Few of the people outside the boundary got affected, public, and of course there was some casualty reported inside the terminal also. So this was the scenario which was identified because this point was very close to the boundary. The planning was done in much before the date of the drill, as we could see from the pre-planning preparation. So there was a lot of deliberations which happened. And the scenario, as I mentioned, I think we need not go into the technicalities. We'll see how the emergency was mitigated and what all went wrong with that. Okay, so the scenario briefly was this: at around 11 o'clock, the main control room received a natural gas leakage, and there was an emergency shutdown which automatically happened due to the detector activated. And GAIL was informed. The Gas Authority of India takes the gas from the send out line, and they were informed to about the emergency. The packed volume of the gas from the GAIL pipeline backflow occurred to the Petronet side due to failure of the remote closure of valves at GAIL dispatch station. So there was a failure of the valves at GAIL dispatch terminal, and the backflow of the gas happened, and that started leaking. There was a 24-inch valve 2920 from where the leak started happening. And level 1 emergency was declared at that time. This was the scenario. So you can see the photograph of the valve which was supposed to be leaking, which was considered to be leaking during the drill. And there were observers from different sections of the industry. At incident site, there were observers from FICT, from evacuation camp, HPCL, incident commander, from the Tahsildar response, FICT again. IOC Kochi terminal posted their observer at District Emergency Operations Center, and at Emergency Control Center there was an observer from TCC, and at the hospital from HOCL. So multiple agencies participated. So the communication flow for this offsite drill was such. The chief incident controller of the factory, for us it is the terminal head, and he has reported the emergency to district collector or the deputy collector disaster management. through a number which is dedicated for the Emergency Operations Center, District Emergency Operations Center, which is DEOC. So this number is well maintained, and it is available in the Emergency Control Center of Petronet. So the only thing which the Chief Incident Controller of the factory has to do is identify that the emergency is going to become a level 3, and then accordingly rush to the ECC and then call up the DEOC. From DEOC, the communication goes to various agencies. As you can see here, the police, the divisional fire, and the district medical officer, FNB, RTO, water authority, KSCB, KSRTC, the Tahsildars, village officers, the local bodies, and the supply officers. So they have various duties to be performed. I'm not going into that. All are defined, well defined in the off-site emergency plan. So this entire off-site emergency plan gets activated upon the communication from the factory manager or the chief incident controller of the factory. The key observations and highlights of the drill were this. There was an incident response system which was put to test, and the incident response system was introduced in India in 2010 by the Disaster Management Authority, and it was as per the Section 6 of the DM Act. This was put into test, and the vision of this IRS is to minimize the loss of property. The IRS has been constituted in the district with the district collector as the responsible officer and the deputy collector disaster management as the incident commander. So here you can see two posts or two designations. One is responsible officer, second is incident commander. So responsible officer is the district collector, and the incident commander for an offsite emergency is deputy collector disaster management. This incident commander is maybe a familiar term with all of us. We also have an incident commander for on-site emergency, right? Like for us, it is the shift in charge operations. Industries follow different protocol for incident commanders, but taking off-site emergency, the incident commander is only one, the deputy collector disaster management. Some other highlights were such, there was a need for improving the awareness among the local public. So this observation would be common for most of the offsite emergency drill which have been conducted in the district or in the country. We need to improve the awareness among the local public. So after this emergency offsite drill, we planned a few sessions through the local panchayat to make them aware of these kind of scenarios which can escalate to offsite areas and what the public has to do in such cases. There are different mechanisms for doing this. Industries in Elur area, I know they do newspaper, they bring out the awareness through newspapers, leaflets, pamphlets. There is a jeep which goes around the public areas informing about what to do, what not to do, not to panic and all these things. So various methods are there. It can be a social media, it can be a WhatsApp group, it can be through conferences or seminars which are arranged at the local body. So somehow the awareness has to go on to the local public, otherwise they will be in a panic mode. There was an observation in this drill that the government hospital in Ernakulam had only one entry and exit point, because of which the ambulance with the casualty had a lot of trouble or heavy traffic. There was a problem in entering the area. So separate entry and exit points will be ensured, has to be ensured in all major hospitals. There was a need to distinguish between level 2 and level 3 emergency siren, but this was in 2020 when the drill was conducted, because at that time the PNGRB siren code for level 2 and level 3 were a little confusing. So this distinguishment has to be proper. Now the siren codes have been made okay, and we all know what is the siren code for level 1, level 2, and level 3. This is automatically taken care by the government. Now, one key observation was the restrictions and the speed limits and spark arresters, etc., have to be followed by the external response vehicles. So most of our industries, all of us have speed limits, the restrictions like restrictions on camera, mobile, etc. And hydrocarbon industries have a restriction that any vehicle entering from outside or even inside vehicles have to be fitted with spark arresters. So these are mostly followed in the industries, right? But during an offsite drill, we could find that the ambulance from the government and the government fire brigade, even the other response vehicles which entered the terminal were not following the speed limit. They did not. They were not equipped with spark arresters, and they were not aware of. Even there was case where one of the government official actually started shooting the offsite drill once he was alighted from the vehicle. Understanding that it is just a drill, started shooting the show. So mobiles, cameras, restrictions in hydrocarbon industries are very important. What can be done in such cases? So we have made a procedure that at the gate itself, the vehicles, any external vehicles entering shall be stopped for a few seconds, briefed about what are the do's and don'ts. Their mobiles will be taken up. The spark arrestor, if not available, will be immediately fitted onto the exhaust of the vehicle, and then they will be sent in. Yes, definitely there will be a small break and pause for this, but it is going to safeguard us in a long way. So this kind of procedural controls have been brought in, and then we'll be checking the evaluation or the effectiveness of this observation in the next offsite drill or the mutual aid drill. Total duration of the drill was 1 hour and 1.5 hours, which was considered to be a little long for controlling. So this is one area where the agencies informed, the observers informed that we should have more speedy response between the authorities so that the entire emergency can be controlled within a lesser time. So how much practically possible this is only time will tell, but then this is an area of improvement to be thought about among all the local agencies. With this, I'll show a small video which encompasses whatever I've told now. And this video will be self-explanatory, and it will allow you to have a better understanding about the drill which has happened. So kindly take some time to share, to watch the video, and then we can follow it up with the conclusion. Can someone confirm whether the screen of the video is visible, please?
Yeah. You go ahead. I will confirm.
Thank you.
Yeah, visible. I hope there is no voice.
Sir?
Voice is not there, only video is there.
So let me unshare and share once again, please. So please confirm if the voice is available.
No. Voice is not there.
Let him proceed. Okay. The voice still not audible, sir?
No.
I paused it just to understand if the voice available.
No, Dilip. Only video is working.
So what I'll do is I'll keep explaining as the video progresses what has happened. Okay. Yeah. I'll do a running commentary. Yeah. This part shows about the surrounding industries of Petronet energy. The layout and the entire premises. The storage tanks, regasification. This is the introduction part. We'll go directly into the So this was the meeting which happened, the pre-planning meeting which happened. And was chaired by the deputy collector, customer. All the committees that are available. They will brief about what's the roles and responsibilities during the emergency or second emergency. The scenario is being executed. The main control room has received the all leakage incident implementation. This is the military station from the gas station. So there is a detector activated. Two gas detectors are able to shut down of the metering station and sent out. One of the plant operator listening to the gas leak, listening sound, the gas across the area, and suffered asphyxiation and consciousness. So these are fire and emergency response team of on site who actually started the response actions. The water curtain, water curtain itself got activated. The same, the fire rescue was the restored one of the cash. Safety and that state team and the Kerala Fire and Rescue Service have been informed firefighting operations. Not exactly firefighting, gas distribution operations will start. Safe control point is activated and have started taking the head forward. Safe assembly point after understanding of emergency can escalate, the point has been shifted to the this joint efforts by the military, Kerala Fire Services, and the on-site team to control the gas leak, the continuous flow of water. Level 2 siren has sounded of the control room. And once level 2 siren has been sounded, in fact, after the level 2 siren has sounded, the military team come into picture, not at the level 1. So there is a communication from the shift in charge of the incident controller that let's make it transferred to outside the body and it asks the chief incident controller to start take the emergency siren for offsite emergency. That was activated and ECC has been activated. The emergency control center for level 3 has not activated. Communication is given to the district emergency operations center. All the people have started getting evacuated outside the terminal. So there is a single point communication between the Petronet emergency control center and the district emergency operations center. Once the communication, then they take over the entire command of the emergency response actions and they actually roll out the on-site emergency plan. The role of observers are to identify faults in communications. So those are various locations. The local emergency operations center was set up at Nambanapada Panchayat. It is the nearest Panchayat. Accordingly, the teams have been populated, fire services, police, and whoever are required for emergency response are guided up to the plants and others emergency through communicating from the and roads in Connect have been blocked by the police. No vehicle traffic is allowed. The entire people in the locality are being evacuated. Application centers outside 1 kilometer from the area. Nearby schools and hospitals and panchayat halls, etc. are identified as rehabilitation centers. An ambulance to the area. Take it the requirements of casualty and response. Next is related to switch off the concept. The public information officer gives the information to the public. The main alerts have been issued to various once the emergency is over, people have been asked to move into the back to their homes or the industry. So traffic is and then after the meeting is where observations have their observations and then they give a proper report of what the was and what were their observations, both positive and negative. So this is how it was conducted, and I'm sorry about the voice part of the video. In case any questions are there at this stage, you're free to ask, else we can move ahead quickly with the closing.
Thank you very much, Dilip. Very enlightening presentation on mock drill. Any questions, please post in the chat box. I will read out, or Dilip also can have a look at it, and quickly any few questions are there, kindly post in the chat box.
So just to answer to one of the question asked by Dr. Ramesh about the globalized, globally harmonized system, GHS, whether it is being accepted in India. I think, sir, if you go through the MSDS format, which is published by PNGRB recently, as a recent update, there are 16 parts for the MSDS, which is in line with the GHS. So India has started slowly adopting the GHS system. Of course, it is not fully adopted because there is no enforcement or any regulation regarding this. But I think in one way we have started, the codes and acts in India have started adopting the GHS
Go
system
ahead.
as well. Yeah, please.
Suddenly your voice trailed off. Yeah.
Yeah. So GHS system is being slowly adopted by the industries, and even the regulators and the government bodies have started incorporating the fundamentals of GHS system through their codes and standards. That is what I was about to tell. Like PNGRB has given a format for MSDS, which has 16 sections. Earlier, as per MSIHC rules, you can see there are only 9 sections required for an MSDS. For as per GHS format, there are 16 sections required. So those 16 sections have been considered in the mock drill, sorry, in the MSDS format by PNGRB.
Adding to what Dilip has said, this now the MSDS which is coming is almost in 16 section format, which is as per ISO 11014, the standard, which is the international standard which is being followed. And if you go through the hazard identification section in the MSDS, which is either section 3 or 4, you will find 2 different categories, which is hazard phrases, as well as the hazard statements, as well as the precautionary statements, which is basically being adopted from the globally harmonized system of classification of chemicals. So that is the thing which is being now followed almost in India also.
Thank you, Vipin. We have a couple of questions more. Maybe Dilip, can you quickly take up? We are running behind schedule. It seems it was well planned. Mr. Amit Katara has written well planned. Is this the only way to conduct a mock drill? And he also adds that female employees were seen wearing sandals, which might be a risky observation. So kindly take it up. There is one more question from Madhuri Depsika. Can medical emergency drill be clubbed with safety emergency drill? Is there any statutory compliance mentioning mandatory medical emergency drill? You can take it in one shot, I believe.
Yes, sir. Am I audible?
Yeah, Dilip.
Yeah. So regarding question from Sri Amit, never. This is not the only way to conduct a mock drill. But
Dilip, you have gone.
Am I audible, sir?
Dilip, you are not audible?
Am I audible now? Am I audible? Hello, am I audible now?
Yeah. Your voice is suddenly muted. Can you come back again? Have you seen the questions in the chat?
Am I audible?
No, not audible, Dilip.
Wait, I'll exit and I'll come back, or
not audible.
So you are audible to the guest section.
You are not audible, Dilip.
You are audible for us.
You are quite audible.
Yeah.
Sorry to interrupt. Dilip
He's
sir,
audible.
your sound is audible.
Okay.
I'll go ahead. So, of course, Sri Amit ji, this is not the way to conduct a mock drill. Of course, we need to conduct surprise mock drills, but being offsite drill, we need a proper planning because there will be public panic, as you know. So, there are no much offsite drills conducted in the state and in the district. So, we are not in a position right now to conduct surprise drills. So, we need some amount of planning. That is the answer to that. Your second question was about female employees observed wearing sandals. Of course, we have also observed it, and after the mock drill, we have instructed strictly that even in non-operation area, because those the female employees which you have seen are actually doing the housekeeping in the non-operation area of the plant, not into the operation or gas zone areas. Even though strict instruction has been informed, and now there is absolutely no one who is entering the plant without a safety shoe. That has been enforced. Regarding Sri Madhuri's question about medical emergency drill combined with the safety drill, of course it is possible, because casualty handling is a possibility, is always a requirement to be considered during a safety drill. But I'm pretty not sure about the statutory compliance mentioning mandatory medical emergency drill. I think if there is someone from the occupational health side who can help me with that answer of that, if any statutory compliance. I'll proceed and give a pause later on. Is speed limit applicable to ambulance? Yes, madam. So speed limit is applicable inside industries just to avoid the accidents. Very interestingly, OISD came for a audit in 2015 in Petronet, 2016 to be frank. And at that time, they asked a very simple question. During an emergency drill or an actual emergency, how fast would your fire tenders and ambulances go? So we told as fast as possible, they'll try to reach the location. But then they gave a very important point that your area is quite small. Within 4 to 5 minutes, even at 20 to 25 km/h, you will be able to reach the spot. And why excessive speed in such locations? So that happened to be a brainstorming for us, and then we have decided during emergency or non-emergency situation inside the plant, the speed limit is going to be 20 km/h. So more than that is not required. This may not be directly applicable for a bigger industry like maybe a Reliance refinery or a BPCL Kochi refinery. They may have to operate at even 40-50 km/h speed. But then more speed, of course, is associated with more risk. Request to share some ISO requirements for emergency. I think I can do that. ISO requirements for emergency drills. Regarding the statutory compliance on mandatory medical drills, if someone else can take up that question. Yeah. Thank you.
Yes, sir. Yeah. Thank you, Dilip. We now move to the next program. Concluding remarks and summing up of the talks by the three eminent speakers. I would request Dr. V.M. Ramesh, Honorary Secretary, National Safety Council Kerala Chapter, to take over. Over to you, Dr. Ramesh.
Okay. Good afternoon to all the participants. This is the fourth time we are observing International Day for Disaster Risk Reduction, and it went on well. The first presentation we had was on learnings from various industrial disasters. That was by Shri CRB, Chemical Inspector, Safety Cell and Officer in Charge of Occupational Safety Health Training Center, Department of Factories and Boilers, Government of Kerala. He has thrown light on various parameters such as flash point, flammable limits, ignition energy, and he also talked about various accidents that has happened in solvent extraction plant, in chemical plant, ammonia plant, and also in steel plant also. Oxygen, this explosion also he has talked about. So a clear understanding of various chemical properties he had mentioned in his beautiful presentation. Then comes our second presentation by Sri Raju PS. Raju PS has given a proactive approach of the process safety management from design to process. He has talked a lot about these things like a lot of barriers that were there from the structural integrity. He has started from structural integrity, then the process containment, ignition control, and on one main thing, the theme of this year is early warning and early action for all. And all the presentations had carried this theme carefully. And this second presentation has also told us about detection system, alarm system, everything, and also process safety management. OSHA standard 3132 also he has talked about in a beautiful manner, and also and he has a process safety and the layers of protection also he had talked, in which also the alarm management also he has talked about. And alarm management is the proper design, that also he has talked about. Stressing the theme of the International Day for the Disaster Risk Reduction, various type of risk, inherent risk and revised inherent risk, residual risk and risk gap also he has talked about. Then another most important thing is the cyber integrity, cyber security he has talked about, cyber threats also he has talked about. And the third presentation by Sri Dilip Madhavan, he has taken us virtually to an offsite mock drill, and he has given definition and talked about the Sentai framework. And we have to have this early warning system within a period of 5 years. That is what the United Nations has told. And he has given a beautiful comparison of disaster management and first aid in his presentation. And the statutory regulation of the disaster management, there are about 15 statutory regulations are there. And major accident hazard industry in this district, there are around 23 major accident hazard industries are there. And he has taken us from the Korba thermal plant to this offsite mock drill at Petronet LNG. Virtually, he has taken us a beautiful video also he has presented. And also, he has also complemented the tabletop mock drill National Safety Council Kerala chapter has conducted during 2022. This is the first time National Safety Council Kerala chapter is conducting a tabletop mock drill. And I think we had a very good number of participation, and I think majority of the industrial workers are interested to have such a type of competitions, because we had 7 types of competitions included this time, and one is the tabletop mock drill. Then Dilip also talked about the communication flow during the mock drill. That is also very good. And he has talked about the mock drill conducted at Kochi International Airport and the jail, railway station, everything. And at National Safety Council, we have shifted to the new building in the year 2019. And we had conducted a mock drill in 2021. Now we had made it a practice whenever we are doing a training program on emergency response system, we will be conducting a mock drill in our building. That is the practice we have taken into account. Okay, these three presentations went on well. I thank all the presenters and I thank all the participants for being with us this day. Over to Nandakumar, sir.
An interesting and informative session coming to an end. We need to formally close the session. I request Srimati Meenu Vijayan, Joint Convener of HSC Forum, to deliver the vote of thanks.
Thank you, sir. Good afternoon to all. We are living in a challenging and uncertain times. Disruption in life has to be proactively managed. That is the essence of today's IDDRR theme of early warning systems and early action for all. I am sure the participants have benefited from today's program. Sri Pramod sir, Director of Factories and Boilers and Chairman of National Safety Council Kerala chapter, has been with us throughout the session. It is his passion and a drive that has helped us in conducting in the National Safety Council programs, including today's session. Sir, we have come to take your guidance and support for granted. On behalf of National Safety Council Kerala chapter and HSC Forum, we thanking you for joining us today. Next, Professor Dr. Anil Gupta, the Director of Projects and the Center of Excellence of NIDM, was magnanimous to be with us in spite of his commitment of other programs today. We were also happy to see him back by joining the session to hear all the other rest talks. On behalf of NSC-Kerala chapter and HSC Forum, we thanking him from the bottom of our heart for his inaugural address. Our key speakers today, Sri CRB, Sri Raju PS, and Sri Dilip Madhavan did a fantastic job by enlightening us on various aspects of disaster prevention and management. On behalf of NSC Kerala and HSC Forum, I thank all the three eminent speakers of the day for their time and excellent talk. The HSC Forum would like to thank Dr. Ramesh VM, Honorary Secretary of National Safety Council Kerala chapter, who was instrumental in getting our chief guest of this occasion. He was also very much part of this program with his active coordination, and many thanks to Ramesh sir. Next, I would like to thank our convener of HSC Forum, Sri Nayar Nandakumar sir, who act as a pillar for the whole activities organized by HSC Forum throughout these days. His compassion and guidance towards this forum made him generating such beautiful webinars, talks, and IDDRR programs like in the past 2 years we are conducting. And I would like to thank sir from my deep heart for the all support granted throughout this program, for the fulfillment of this program. And I would like to thank each and everyone who had supported us to organizing this year's IDDRR program. Especially, I would like to thank Jayakumar sir, Vivin sir, Vinod sir, then Radhakrishnan sir, and the other HSC Forum committee members for this program. Also, it was delightful to see a good participation for across all industries today. We had close to 100 participants today. I am sure all of you have benefited from today's program, and there was good takeaways for each of you to make our workplace safe and secure. Thanks to all and all of you for the overwhelming participation towards us. Thank you. Thank you.
Thank you very much. We will now close this session. Thank you all. Thank you, Mr. Amit ji.